So, okay, so I think all of you have joined. Am I audible right now?
Yes, sir.
Okay, it's like properly audible, right? Okay. So let's start with this today. So it's week three. I think it's a summary session for week three. What do you? Uh, so are you comfortable with week one and two content till now? So whatever is have taught in the week one and two. So probably week two is the difficult week among these 12 weeks, I guess. And okay, I hope like all of you are fine with that content. So we are starting into this new. Yeah, yes, Tanish. Anybody who wants to say?
Excuse me, sir.
Yes, sir.
Sir, in week two, I could not understand the ninth and tenth question of the graded assignment.
Okay. Okay, but the solution is available, right? By that solution also you are not able to understand.
No, sir, I'm not able to understand the concept behind it.
Fine. Okay. So let's keep it at the end. Maybe after the session, right? So you just remind me. We'll take that
Okay, sir.
from you. Is that fine?
Okay, sir. And sir, on every Friday in the calendar, it's showing three simultaneous MLT sessions.
No, no, no. So that will be changed. So right now we haven't changed the things, but it will not be like that. So maybe I'll just remove those sessions
Okay,
right now. Those sessions will not be like this,
okay.
right? So let me do it.
Yeah, a lot of fluctuations are happening right now in the MLT sessions. Like they're constantly changing every day.
No, right? So I think only instructor sessions are happening on Monday and Friday, right? There is no change in that. Where is uh, I think TA sessions only last week, I guess we have changed it,
Okay,
right? So
okay.
yeah, yeah. So see, generally the regular thing is uh, your MLT session on Monday, right? So that will be when the summary session will be on Monday from 8 to 10, and Friday the session will be there. The solve the session it is from 6 to 8, right? So maybe Friday session we will postpone it to 8 to 10, but not like if it is not required, it will be like this. So instructor sessions will happen on Monday and Friday. The timings will be on Monday session it is 8 to 10, and Friday it is from 6 to 8. Okay.
Okay, and on Thursday and Saturday, it's showing week one and week two sessions again.
No, that's what I'm saying. It's like the previous sessions are there. We will change all the this week, right? I will change like all
Yes.
the calendar, so
Okay, sir.
those will become proper.
Okay, sir.
So tomorrow's session is also there from 6 to 8.
Tomorrow session, yeah, it should be there, and I think I should change the time name of that session. It is should be week three, right? Okay, so I'll change it. But see, I think the lot of changes has to be done on this calendar. We'll do that changes. Fine. Right now, so instructor session they are like on two days. Fine.
Sir, I have a doubt in covariance. Can I ask? A very small doubt.
Yeah, tell me what is it. Like
Sir,
if it is possible for me to explain it right now, I'll do it. Else, I'll at the end of the session, right? So I'll.
yeah, sir, actually, the thing is, sometimes I see 1 upon n as covariance matrix formula, and sometimes I see 1 upon n minus 1. How
Yeah, so
both
generally
are
people,
equivalent?
so if you have done the statistics, right?
Yeah,
You
yeah.
done the statistics previously, statistics one basically. So if you remember, there are two concepts. One is population variance and sample variance, right? Do you remember that?
Hmm.
The
I
distinction
think from there.
Yeah, so there is a distinction between the population variance and the sample variance, right? Or here also it's kind of the sample covariance and the population covariance. So some of the books, right, they refer it as a sample covariance. So in that case, so whenever you deal with any sample, right, so what you do in that formula, uh, the what is it? In the denominator, it will be n minus 1 instead of n. So that is the difference, right? So when you wanted to see this data set as a population, then you find out the covariance by dividing it by n. And if you think this data set as a sample coming from certain population, then you can say that it is in then you treat it as a sample, and then the formula will be changed as 1 upon n minus 1. But if you ask me, right, for large number of data, if the n which is very large, right, in that case 1 by n and 1 upon 1 divided by n minus 1, right, it will not make a lot of change, right? So that n minus 1 comes to to it's a bias correction, right? If you remember it from stats days, that is used for a bias correction in sample. Fine, so it's fine, like you, but in our case, in if you consider this MLT syllabus, right, we will not be seeing 1 upon n minus 1, it will be 1 upon n throughout the covariance matrix.
Okay, sir. And in question, they will give us na कि this is a sample data or a population
So
data.
whatever it is given to you, right, whatever is written to you there, the covariance matrix, you think like for this course you should be calculating it by using 1 upon n into, I think it is x transpose x, right? So that way only
Uh-huh.
calculate. So don't worry about if it is sample also written, if it is not written anything else, still you will have to calculate by 1 upon n formula. Fine.
Okay. But what about gate exams and all in those papers?
There it will be different. So there they will mention, right? So what you need to I see in generally get papers, right, they don't ask you to solve any questions by formula. Generally I haven't seen like much about it. If it is there, they will mention it clearly. Fine, so that is there.
Okay, sir. Okay, fine. Thank you, sir.
Yes. Any one else? No, right? So okay. So shall we start for week 3 then? There are like two questions, right? I need to explain for grade assignment 2. I guess week 2. We will do it at the end. Right now, we'll focus on week 3. So what we have started is we have started with unsupervised learning, right? What is and what is the difference between unsupervised and supervised learning? Can you know?
Labels are available.
In where?
Supervised learning.
Supervised learning, right? So uh, yeah, so what difference it make if you have this labels available in a data set?
We can train the data.
And there is some feedback it is getting. So it is
What feedback?
supervised, and then it is learning, and it is getting
So
the
are you
feedback
not
also.
learning anything in unsupervised case?
In unsupervised, there is no feedback. So,
No, there is no feedback system in here also, right? So in supervised or unsupervised case, is it correct? What kind of feedback we are getting it from the supervised case? Anyway, see, we are yet to deal with the supervised learning algorithms, but I think from MLF time you may have understood this. What is the difference between supervised and unsupervised? Yes, with you.
Yes, sir. So in unsupervised learning, we use like PCA and all these things to come with variance, and we don't have any training data set to know that whatever model we build is similar to, say, it's a line, and in supervised learning we have that y value for each x value that we can check later on. But in unsupervised we don't have that target variable, so then we have to just do it with another method, like what we did with PCA and stuff. I don't. Maybe that's those are my thoughts.
I think in
The training.
unsupervised learning,
Hmm. Yeah, go on, go on.
there is no predefined outcomes where but in the supervised learning, we have an outcome that is predefined. We can categorize it, but that's not happen in unsupervised learning.
Okay.
So in unsupervised learning, we learn about data, but in supervised learning, we have the what is this data? Is what is the we only have to find the relation between the data to get that label.
No.
It's a pre-processing task
Both,
of
see, both of these learning algorithms, right? So these are like, okay, not learning algorithms, both of this type of learning, which is supervised and unsupervised, we try to learn from the data. Is that fine? So see what we are doing here in machine learning generally, it's just like we are training our computers to learn from the data, correct? There is a distinction between supervised and unsupervised, is only that the supervised learning, the data which we are having, it will have some labels associated with it, or you can say that there is there is an dependent variable which is given to me already. What do you mean by dependent and independent variable? So let's say in case of house price prediction example, let's say you wanted to predict the prices of the houses, right? But on based of what, like there are few features which are, let's say, the area of the house, the distance of it from the the metro station or the railway station, right? Or from the nearest school or the nearest hospital, right? So based on, so these are all features, right? Like the area, the distance, these features, they are independent of each other, but the price of the house will be dependent on these features, right? So in supervised case, you have the information about this independent and the dependent variable, right? And what you try to do is you try to predict the dependent variable based on the data which is available to you. So we train our models, and what models are these to train? These are all the mathematical models, right? So mathematical models means we try to under, so in case of regression, we try to understand this linear models, right? So where we try to predict what will be the price if these features are like this, right? So that is what happens in supervised case, right? Or you try to classify data based on, but whenever you try to classify, your data will have already some examples to learn it from, correct? So let's say if I wanted to classify a cat's picture or a dog's picture, you have before learning anything from you already have a data where it is clearly given the labels associated with those. Let's say if any image is given to you or any photo is given to you, you have the label associated with that, correct? So likewise, that is what we are having in the training phase, and then based on the training, right, we try to learn, and or the machines are trying to learn it from that data, and now then you can actually use that to predict for the unseen data. So there will be two types of data, which is seen and unseen data, where in unseen data you do not have the labels associated with it, right? So that is one. For unsupervised learning case, right, you also here also you have a data, fine, you have a data, but those data points will not have the labels associated with it, or there is no.
Sir,
Yeah,
are you sharing screen or not?
no, I'm not sharing the screen, right? So what I'm trying to say is, like, if you have this kind of data where I do not have the specific label to it, just bunch of data points are there, right? They may be dependent on each other or independent, but let's say you do not exactly know what to predict, so there is no prediction point available right there, so I do not know what to predict out of it. So what you try to do there, so maybe you use it for, so like PCA, right? What you do is you try to reduce its dimensionality, right? So that means, let's say if your data is lying into a lower dimensions of space, you try to reduce its dimensionality, right? And maybe use that data now for the next task. There is one more thing which is which, like, let's say in clustering process, right? What you try to do is you try to group the data points, fine. So is my screen visible to all of you?
Yes, sir.
Yes,
So
sir.
yeah, so now we are going to learn about one more unsupervised learning algorithm, which is, let's say, it is a clustering algorithm. Okay, just a minute, I need to hide this. Fine.
So this is the first part of supervised algorithms, right?
No, this is not supervised. This is unsupervised again.
Okay.
So here
So
also,
in that,
yeah, here also the data set which you are given, right? So the data set will look like this. So let's say if capital X is a data set, right? It will have data points, bunch of data points. Let's say x1, x2, x3 to xn, but their corresponding labels are not given. If it is a supervised case, right? Then this data set will be like this. This data set will look like this. It will have the pairs, right? So it will be in pairs. X2, Y2, X3, Y3. Y3 is the label, right? So we know that for this kind of uh, data, right, this kind of set of features, what is exactly the label for it? Maybe it is a price, if it is, let's say, a regression case. If it is, or maybe it is a classification case, then you know that, okay, if these are the features, if I see, it may be called it as, let's say, if it is a cat's picture, or it's a dog picture, or it's a car picture, or it's a person image, like that, right? So that is a distinction between these two learning algorithms. Currently, we are in unsupervised, paradigm. So we are currently also we are actually thinking about what is exactly the or what we can do apart from PCA in case of unsupervised learning. So that is
Sir,
what.
the purpose of clustering is to see the patterns in data only, or it's used internally for any other machine learning algorithms?
So again, it's just, see, all of this, right? All of it is actually, the machine learning is related to what? Understanding pattern in the data, correct?
Mm-hmm.
So that is, anyway, it is there. So here also we are trying to find out the patterns, but in a different fashion. So we will see the distinction between what is PC and clustering here. But let us try to understand first how this data set will look like. So these are all features, right? And when I say xi, each xi is in d dimensions. What does it mean? You have d such features, right?
Yes.
But again, see how to understand that, what okay, what is this exactly, right? So these are like, okay, you can actually see it as, or visualize it as, like maybe a practical scenario, or maybe you can think of it like, okay, I'll just maybe give you the brief example of the same data set. Let us say I wanted to show. So have you seen the handwritten digit? Okay, maybe just
Can I ask something?
yes, you can ask.
Sir, you are talking about MNIST data.
Yeah. Then,
You are just explaining the algorithm, or you are also explaining it with the numerical example?
no, I have not done it anything yet, right? So we are just discussing about what is the difference between supervised and unsupervised. Later on, I'll dive into this part. Fine. So when I, okay, just see this image. Are you able to see the image here?
Yes.
yes.
Yes, sir. Very clear, but okay. What are you able to see this? Maybe let's see if it is. Okay. Are you able to see this now, right? So
Yes, sir.
what is happening here? This is what the image is, right? But the corresponding label is given to you here, right? 2, right? Here below it is 4, below it is 3, below it is 7, below it is 2, like this, right? So each of this image, if I have this kind of information available before learning maybe any mathematical model, this is what it is called as supervised
So,
case.
yep.
Fine.
Supervised.
Case, right? Because for this, so how many features does it have? Does one image will have?
28 cross 28.
Yeah, let us say if it is a 28 cross 28 pixel image, then you have that many uh, x, right? Small x's, let's say. And what is the label here? Corresponding label?
2.
Y is equal to 2. For this image, you have different features. So let's say 28 into 28, how many? I don't know. Let's say,
785.
yeah, so let's say that 700 or 800 features are there, and corresponding label is given to me. That is my what? So here, what is your what are you going to so if you learn on this data, what are you trying to predict later on? Suppose if this kind of image is provided to me, right? I need, so my machine needs to say that this is a image of number 1, right? Is that
Yes.
correct?
Yes. And so you're saying that so the data set would be some X vector with 784 dimensions and comma Y, which is
Correct.
the value we have.
Yes. So that is like, let's say you have how many examples? Suppose this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 20, 30, 40, 50. So if your n equals to 50, right? So here how it will look like, let's say if I wanted to write each of this in terms of data, so that data will be like each of xi is of how many dimensions? Let's say 28 cross 28, so that many, and corresponding labels are given, and here I equals to how many,
50.
right? So I don't know whether I correctly so here n equals to how many, 50. So I have 50 examples, right? And each of this example will have how many dimensions? That many. So I think whatever you calculate it later on, and then each of yi is given to me. So I have, how does it will look like? So each of this 28, so it will be a it will be an array, right? So because each pixel will have certain numerical value, correct? So how many, 28 by 28, can anybody tell me what is
784.
784.
Yeah, okay, 784, right? So it is 784. So in that case, let's say if the first image is there, right? So if this image is there, it will have, let's say, value of 5, right? If you know the grayscale image, I think it will vary from 0 to 265, right? So it is 266 something numbers. So since there is no, so if you take one smaller corner of this, it will have lesser value of so it is like not the gray scale, it's like the normal scale, right? So it will have like lesser numbers, so it will
So
have
basically in this color scale from 0 to 256 based on the shade, right? Like how the
yes,
computer is recognizing as a
yeah,
unique shade or something.
correct. And this numbers are associated with it. So if it is
Okay.
very dark, right? So it will have, let's say if let's say 50 50th of this, right? Maybe the feature, it will have, let's say, 255, let's say, right? So in that case, what will happen? It will be a so we know that it might be somewhere here, right? At this point, somewhere here, correct? So like that, and what will have, so these are all so
So,
each,
sir,
this
in MNIST dataset, hello, sir, I have a doubt.
yeah,
In MNIST dataset, we are exploring only single image, like any number we have two, let's say. So we are studying to finding the pattern in only two. Yes, sir.
no, x1 is equals to 2 right now, correct? I'm saying that, okay, I'm saying this x1 is this one, entire image is 1 x1, this is x2,
Mm-hmm.
this is x3, this is x4, right? But
It's
in that,
basically been flattened to
So, sir,
784.
what will be the feature here?
sorry, what will be
Feature columns.
this values, right? No, not column.
Pixels of x1. Pixel of x1 will be features.
Okay, you need to understand. Okay, maybe you guys,
Mhm.
okay, fine, it's okay. Let's say you have this 2 right here. This is what I have written it here, let's say.
Mhm.
Are you able to understand this 2? I think yes, right? So let's say this is my handwriting, right? Somebody will
Mhm.
write in a different way, but let's say this is what I write, fine. Now you do one thing, you just so pixels means what? It will be like uh, all this, no, boxes will be there, right? It will be this, 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 right? So this one, right? This one is first
Mhm.
feature.
Pixel. Okay.
This
Mhm.
feature one. This is second feature.
Okay.
This is third feature. Fourth, fifth, sixth, seventh, eighth, 9th, 10th, 11th, 12th. And let's say 12th, right? Now it will have some white portion and some this blue portion, or let's say it is a black portion. So it will have that kind of value associated with it. So if it is very white, right, then it will be very close to the value 0, right? If it is some color is there, that means, but it is not entirely dark, right? So if this kind of let's say this box, right, it will have much more value, like it will be towards this 255, it is 245, right? This one will have, let's say, 185 or something like that. So these are the values. So each of this pixel is one feature, right? And its corresponding label will be what? 2. Correct? Understand?
Yes, sir.
So the next x2 will be what then? X2 will be another flattened array of
Image.
right. So it will be like all again. It will be, so it will go from 1 2 3 to how many features? 784 features. Is that fine? And its corresponding label is 4. Fine. You understand now?
Yes, sir. Yes, sir. Yes, sir.
Like that. So you have all these things in a all these values available to you and corresponding labels available to you, and those are all in what? In case of training. Fine. Now now what will happen is you have learned some mathematical model out of it. Now what happens is I give you one more picture again. So it is, let's say, 8. Okay, I'm just changing the color, but you think that like this is the same.
But sir, it has to, like, if we are going to something new, we are going to introduce, should it have to be in the training data set?
If
Like
it is
the
not
label?
no, not required. It can be anything. See, that's what. But generally, see, you try to generalize it, right? What is it exactly?
So my question is, say we are training it on 1 to 10 handwriting
Yes.
analysis. Now I
Yeah.
put 74.
Yeah. So
Will it recognize
it will not, it will not be able to recognize it, right?
Okay.
It will
So only
recognize
1 to 10 it can recognize.
basically, yes. Then
Okay.
because you are serving that purpose, so it will be actually going to recognize it that way. So you know it already, but anyway, we are going to learn about the training error and the test error later on. Like in this course itself, we are going to learn. But right now, you just we are actually confined in this 0 to 9 thing. Is that fine? Okay.
Got it.
Now, so
Yes,
you
sir.
have, yeah.
Sir, how you are putting those numbers? Are you taking randomly?
So there is a data set available, right? So I'm not putting it anything. So I'm just taking it from this data set. Let's say you have given this data set with you. Which numbers you're talking about? The inside numbers, huh?
For X1.
Here, huh? Okay, I'm taking it randomly, but generally, if you understand, so I don't know, you guys, maybe you just learn about this thing, the grayscale image. It is grayscale image, right? So for any image, right, or any pixel, right, it depends on the color. So the if you have value equal to 0, right, in terms of numbers, then it is more towards white, right? And then it will have, if you go to 255, right? So I think 255, yeah, I think total 256 numbers are there. So it will be 0 1 2. So as you as the shade of the gray increases, right, or it will become darker and darker, the number will go higher and higher. So it depends on that. So it's again that is a different kind of study available. Learn about this on internet. So it is available everywhere.
Sir, if you zoom this here itself, it will show that gray.
No, you learn it later on. See, if I try to delve into much about it, right, then it will take a lot of time to finish this session. So I'm just trying to give you some idea. You just don't worry about these things. This is like you may understand it later point of time. The idea here, what I'm trying to say is that what is the difference between supervised and unsupervised? Fine. Is that okay? See, is that fine? So if I see, I can tell you what is it exactly, but then again, it will like waste a lot of time in that, and it is not useful right now. This for this kind of whatever we are trying to do here, right? Okay, now you just see this image. Okay, it is there. Yeah. Are you able to see this image?
Yes, sir.
So yeah. So you can see here, right? This data set, which is if you are see here, do you have any labels associated with it? All of this data set, like all of these values?
No.
No, right?
No, sir.
No, right? So, and okay, I think those who have wanted to understand this, so it is like, okay, 1 7, right? So is it 7 or is it 3 now?
7.
7.
It could be 3, right?
Yes, sir.
Yes, sir.
Right. So if I do not give, if I do not get any particular information about the label, or let's say if it is, you assume it as, see, we are humans, right? We are trained on this from the childhood. So we are easily able to distinguish between this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But let us say if you are a computer, or if you are a new, like, or maybe if you are a child, right? So will you be able to recognize, or will you face any difficulty in recognizing this if it is not given you as a label? Is that
Yes.
correct?
Yep.
You may call it as 3, or you may call it as 7, correct? Like how
Yeah.
you are trained on.
Yes,
Maybe,
sir.
maybe you just, so you, maybe you will be clearly identify this as 2, but what about this? Maybe a child can go and identify this number as 6. Is that correct?
Yep.
There is a possibility, right? There is a definite possibility. Maybe similarly for this number also, you may end up in identifying it as number 6, correct? Fine.
Yes.
So if I do not give any labels to you, what you are trying to do, let's say, or you or let the machine, what it will trying to capture here, it will try to capture the
The
shapes,
most likely
the patterns,
shape.
right? So what is the shape of it, and it will group together, right? So it may group this, right, this figure, this figure, this figure, so all of this, right, into one group. Probably this one, it will group into this category. Is that correct? In 0th category. Fine?
Yes.
Because it is like, it is kind of similar to 0, right? Maybe this one it will group into 1. Is that correct? So that means if you do not give the labels, if you do not have the labels, what you try to do, you try to group them, right, based on other features, or based on the features given to you. Is that fine? Now you understand the thing, like if the labels are there, you know that okay, I need to categorize into this particular categories. So that the previous example we have seen here, what should be your goal? If the unseen data comes in, whatever the data will be there, you will group it in, or you will categorize it into between like the number between 0 to 9, right? Definitely. Is that correct? Because we know that the labels has to be between 0 to 9. So maybe the label should be 0, the label should be 1, 2, 3, such that to 9. Fine. But in this
So the
case,
basic.
yeah, the goal was
So
different,
we're,
right? Yes, yeah. Go
so
on.
basically, we're trying to, here now we don't have labels, so that's why you're doing the clustering and stuff.
Yeah, so because you can't do anything about it, right? So how the machine will know that I should be categorized it into the labels? No, right? There is
Yeah.
no such way, because how do it know that this is 0, right? It's a clear slate, right? The machine, it's kind of a child, right? So if the a small kid, if it is there, and if you don't tell that kid that this is 0, 1, 2, or 3, and you just give some random, let's say if you make this toys out of it, and if it give it to you, what the child will do, it will group it based on the shapes, right? Because the child may not know, or the kid may not know this is 0 or this is 1. Is that fine? And likewise the machine also will do. What it will try to learn, it will try to learn the patterns out of it, right? Maybe this thing here which is available, it may group into this in this group, or it may group into this. So it depends on how it is going to learn that pattern. Is that okay?
This is what we're learning now. So
Yes.
basically, right, in this week's
Yes.
portion, like
Yes.
how it's clustering and how it's
Yeah.
going to identify it's a 6 or whatever number.
Yes. Not not the exactly the value, but how to group this points, right?
So okay. So we can't derive a value. It won't come up with a value.
No,
We
because
are
we are
just
not
putting-
classifying it, right? We are not categorizing it. We are just making the groups. Clustering is what? Then grouping. Right? And grouping based on what? Maybe the maybe the
Similarity.
shapes, or maybe the similarity. How similar these data points from each other, right? Based on that, it will try to categorize. Right? Is it the distinction is understood between the supervised and unsupervised?
Sir, in the previous example, you're taking x1 and x2. There are like what numbers you are passing? Are they like xy coordinates or? it is getting reshaped, no, anyhow, in
Here
order
you
to form the image. So, yeah.
these numbers you're talking about.
Yeah. So even though you take it as a vector, no, when you form image, you have to reshape it right to 28 cross 28. So what these numbers mean? Do they mean x by coordinates or?
There's basically a scale, and then you just put like upload the picture, and it'll give you that okay, this picture. It'll just put a number based on like the shade the computer recognizes.
Okay.
I don't
Let's
Can
say
we go to the next part, sir? Because
yeah. So let's say you have x1, right? So these values are like this: 5, 10, 15, right? And like that to because this is a vector, right? And it will be vector of how many? Let's say it is 784. So maybe I'll just write down the dimensions here. Fine. So it is 784, and suppose it is here maybe 255, 230, and like that, and it goes and end up with, let's say, 3, 5, something like that. Is that fine? This is okay. This is one image, right? X1 is one image. Is that fine? It is 7 cross 1. So, but let's say if I give you one example which is of R2, let's say if your X is with R2, right? Fine. So now if I say that X1 is equal to 2 and maybe, yeah, 2 and minus 1. So how will you draw it on x1, this axis? Let us say this is x coordinate and this is y coordinate. Two features are there.
Below.
This is one example given to you.
In second coordinate.
Fourth coordinate.
X1. So it will be 2 on x-axis and minus 1 on this. So this is the data point, right? So this is a vector in this. So consider this is a 784 dimensional vector. We are not able to draw it, right? But you understand the point about it, right? So you have these two features, right, available to you, and this is what the example is. This is one x1 as the example. So what we are seeing that x is a data set of this such examples, and you see that that image I have broken down into the numbers, and now I'm trying to think this as a vector. And now how many such vectors are there?
50.
And yeah, so
10.
or 50 vectors are there, and now you have those vectors out there. Fine. But let us say if all out of this all the vectors, right, let us say for each vector the remaining let's say from 600 up to 784, right, the values are 0 for all x1 to x1. For all examples you have seen that pattern. What does that mean? This data is actually lying into a lower dimensional field, lower dimensional subspace, right? Is that correct? Because you have 600 values available across 50 examples and not the other ones, right? So your data set basically will become a matrix. And what dimensions of this matrix is? 784 cross 50, right? Is it okay?
Yeah. So I may ask something.
Yeah.
So I was not able to understand how this x1 dimension is 784.
Because each of this image, when I talked about, right, it was it's an image of 28 cross 28 pixels, right?
Yeah.
What are the pixels? This small, this is one
small
pixel, right?
blocks of
Yeah. So how many total are there?
784.
So you have this 784 numbers, right, for each of this block.
Acha, acha.
So these are all 784 numbers. Instead of writing into this format, I have written into a vector format, right?
Okay, so each block represents each row represents each block.
So
Next
each block is each value here.
Yeah, got it.
So the second value is this one. The third one is this one, this number. Is that okay? Now is clear?
Yes, clear, sir.
So now this entire matrix is 784 by 50. Then that means each of xi here, and what is this 784? The dimension, right?
Yeah.
And this is what? D cross
Number
n
of
matrix.
vectors. Yeah.
D cross n matrix. But I'm saying that each of along all of this x1 to x50, the 184 dimensions, right? So after 600, all of the values are 0. So that means do I need all these dimensions to require for any purpose? So the remaining
sir.
ones are of no use, right, to me, let us say. I can perform PCA over it, right? And I make those dimensions go away, because that was what our previous understanding about PCA was, that if the data lies in a lower dimensions of space, what do? You try to apply PCA over it and try to reduce the dimensions. So then you will get the reduced dimensions in this format. It will be W1, W2, and like that up to Wn, right? And so n here will be 50, and these are what, like, these are the I think X transpose X, right? X transpose X. This is covariance matrix. These are all the eigenvectors of that. And
Sir, isn't it X into X transpose
yeah, I think both are
in R notation?
yeah, okay, that is X transpose, right? Okay, fine.
Yeah.
Is it okay? Yeah, I think it is D cross N. That means D cross N and N cross D. Yeah, correct. So it should be X transpose. So, do you have now this? You don't need to go for, I think, okay. How many? Okay, how many? Let's say K, right? You don't need. You will not go for D. You go till K, right? And each of Wi is of what dimensions? I think it is 784. Is that correct? Yeah, I guess.
Yes.
Yes, and here the K will be what? It will be lesser than D, right? So the K will be less than D. Is that fine?
Not necessarily, right? In our case, because there's so much like white in the image.
Yeah, but
Less
so
than equal to.
that is what actually we wanted to achieve, right? Then otherwise there is no point in applying PCA. If my data is not lying into lower dimensions of space, that necessarily means what? Then if it is not, then that is fine, right? So leave that, like, keep the data as it is, because PCA is not going to lower its dimensionality anyway, right?
Got it.
Fine. So, but we are assuming that, okay, the data is lying in the lower dimensions of space, and I have used the PCA over it. Fine. That is what one thing we were able to do it. But there is one more thing to it, right? So what is that? So that is what we are trying to learn today. Maybe we were able to reduce dimensionality, but there is another case possible, that let's say this was your data, right? Let us say it was yeah, I hope you are able to see these data points, right? Is it visible?
Yes, sir.
Okay, is that fine? So for this kind of data, what we did, we knew that the data is lying into a lower dimensions of space. We apply the PCA for it, let's say, and what we are able to get, we're able to get. So initially the data was in how many dimensions? 2 dimensions, right?
783.
No, here. Now, in this case, no, leave that behind now.
Okay.
Whatever you have seen, right? So currently, this data points which have,
Two dimensions.
right? So each of this data is in 2 dimensions, right? But we are able to see that this data actually lies in lower dimensions
One
of
dimension.
space, and now we are able to find out such a line here, or maybe this is what W is, right? Or maybe you can use W here, right? So it's like kind of okay, sorry, maybe I'll just use it here, the normalized version of it, right? And so let us say this is it fine? So
That's a unit space we're taking.
correct, and
Okay.
we are saying that, okay, along with that we are able to find out this W line by using the or we will try to represent this data into single dimensions of space. Is that fine now? Till now it is okay, but there is a possibility that what we are missing out over here is, if you understand this data again, this data, right, it may be similar to each other, these data points, they behave similar to each other. Is that correct? Right? Can we group it? Can we group all of these data points, right, such that or maybe or group it, or in the now we are whatever we are going to say now from here onwards, it is clustered. Can we able to cluster this data set? Can we able to extract some patterns out of this data set? Or it's just not like lowering the dimensions, but maybe we are able to see some other patterns. For example, I have seen you, right? So for this purposes, right? So maybe if this kind of data points are there, right? So each of so for this data point we have some values given to me, right? One vector of values is given to me. Is that correct? For this also one vector, this also one vector. But now what it will try to do, the vector of this, right, and this might be closer to each other. Is that correct? In the appearance, the values will be very closer to this and this, right?
Yes.
Yes, sir.
Compared to this. Correct, right? Right?
Yes.
Yes. 0 and 1 will be far away, and
0 and 1 maybe like very far away, but 0 and this 0 will or this 6, right?
6. Yeah.
Maybe it is
Yes.
very close to each other. Possibly this also is closer to each other, or oh sorry, not this one and this one may be closer to each other, the values. Right? So and we try to group this. So based on what now? Based on shape, right?
Pictures. Yeah.
So what is the similarity here in the data? The shape. All right. So previously what we have done, let us say you had this many values, right? Where 0. So what we were able to do, we were able to reduce the dimensionality using the PCA. But what it does, it will, let's say, blur the image, right? Maybe.
Yeah.
Correct. Blur in the sense like we don't need like so much of the information. We are removing that information. That means we have reduced dimensions. But yes, it will blur the image, but the shapes will be there, right? It will
Yeah,
be
because it's the most likely face, as Sir showed in previous lectures,
right. So
that it's the most likely face among the
correct.
faces.
Yeah. So that eigenfaces example, right? So what happens there? You just see that you don't need like all dimensions, but you need the like lesser dimensions, right? Here also we don't need, let's say, all dimensions. We need lesser dimensions. What will happen? What it will happen? It will blur, but the shape will be there, right? And we use that shape as a similarity pattern, and we can actually club them based on the shapes. Is that fine? Now, is it okay?
So like among all the zeros, one like most likely 0,
They
and then
will
among
have,
them
yeah,
we'll keep clustering.
correct. Because if you understand these data points, right? So this is one vector, right? Each data point is a vector here. Is that correct?
Yes, sir.
Right. So that means whatever vectors. So, and what we have done here also, we have plotted all the vectors, right?
Yeah.
Yeah. And so if you see that, like this, the vector for this and vector for this, right? The numbers might be very close to each other, right? So that means if I try to draw, so 0 and 0, right? These all vectors will be like very closer to each other. But maybe
Okay.
7 may be here, right? All 7s, you might see these we'll towards this direction. Understand? So
Yep.
we'll take
Yes,
all
I get it.
as 1 and this as 1. Because why we are able to do it? Because okay, that's how it will work, right? These are the vectors in the we are not actually seeing the pictures. We are seeing them as numbers now, and we are trying to plot these numbers or this as in terms of vectors. Now if you see that, it will have these numbers going into certain directions, right, for these shapes. Because if you see that into this, right, exactly for like nearly the same kind of pixels, right, it will have that kind of values trigger out. Correct, right?
Because that like the value in that xi vector is similar to other xi vector
Correct.
values in
Correct.
that space. Yeah.
Fine, right? So I hope you are understanding now, like getting there. Okay, fine. So that means what we can be we can actually learn these patterns also by using any unsupervised learning method, and that method is what? It is clustering. Okay, so we are going to do that now. I'm not going to refer to any real life example. Now we will just deal with the what is it, mathematical things. Is that fine now? Okay. I think at least the picture is clear in your mind. Now we will try to assemble that picture and we'll try to understand what is this clustering algorithm is. So today we are going to learn about k-means clustering. Now what does that mean? We'll see that a bit. So k-means clustering is the algorithm we are trying to see, and whether it will work or not, that also we'll see. Work in the sense the convergence criteria about that k-means. Okay. Okay. Till now, all of you are clear. Can you just thumbs up once? Like it's fine.
Yes, sir.
Yeah. Are you guys listening to me? Only press
Yes,
yes.
sir. You're not seeing the thumbs up.
Yes, sir. We are
I am.
listening to you.
Okay.
So you don't get to see the thumbs up, like.
Yeah, I'm able to see.
Okay, okay.
I'm just seeing the same person.
Sir,
is
your,
like,
sir, your voice is somewhat breaking.
Is it? Am I audible to others or no? Right?
Yes, sir. You are audible.
Yeah. Okay, maybe there is a problem in your network, I guess, right? So yeah, fine. So let us start with this. Now, what is our goal here? Goal in this clustering case is what? You have bunch of data points and you wanted to group them into. So in this case, in this figure, we have seen how many groups we can actually group it into.
Three.
So we are going to group it into the 3 clusters. So you have data points. Each data point here is in how many dimensions? D dimensions. Fine. So that is our classic thing. Like, okay, we are going to have this D dimensions, and how many dimensions or how many finite clusters we are going to partition these data points into K. So K should be a finite number, right? So if it is a finite number, then we call it as we are able to successfully apply this clustering algorithm. Okay.
Okay, sir.
But how many ways we can do for such case, right? So I think sir has taken one example there in the lectures, which is what, like you have, let's say 5 points, 5 data points, x1, x2, x3, x4 and x5. If you have these 5 data points, in how many clusters can you, okay, how many clusters, this K clusters you can actually form? I can actually form one
At
cluster,
most K power n.
right? So yeah, we can actually have one cluster up to 5 clusters, right? Correct. But let us say if I wanted to do that K equal to 3, okay, then how will you group this into three clusters? How many possible clusters are there?
5C3.
To the power 5, right? No, so let's say you have 3 clusters, no? K1, K2, K3, and you need to, so for each of this, right? How many possibilities are there? So for first, it is
So, but
5 or
3.
3 to the power 5 or 5 to the
But if we write 5 in every block,
When empty bins are allowed, no?
Sorry?
Like this, when empty bins are allowed.
5, 4, 3. If no repetition is to be done.
Yeah, anyway, the repetitions will not be there, right? Okay, so I think it is how many
5 choose 3. And then 5, 4, 3.
Yeah, 5, 4, 3.
5 choose 3. Okay, so let's say you have total 3 clusters and you need to
5 choose 3 only, sir.
yeah, correct. So that is correct. But one more thing, let's say, yeah, five choose 3 is fine. One more thing I wanted to ask you is that okay, you're saying that 5 choose 3, then 5 choose 3 is what, like 5 factorial upon what is it,
3 factorial into 2 factorial. Yeah.
right? So 5
Yeah.
4 3, no, that is wrong, right? So
It would be 5p3, no?
5p3.
so how
5p3.
it could be
So that is when in each pin we put only one
let us say
point,
you have
but in this
K1,
case we can put multiple
no,
points. No?
see, K1 K2 K3 is there, and let us say each, right, it should have at least one uh, uh, it can go like at least one, right, here. So you have 5 choices here, 5 and 5, right? I think it is 5 to the power 3.
So, but it will be
Sir,
repeated.
why is it not 5 choose 3?
5, what is 5 choose 3?
Out of
Choosing
5 options,
No,
you're making
what are you choosing?
combinations of
Yeah, but what are you choosing
without.
here? You're choosing
3,
clusters, right?
3 per member
Not like
3.
that. Okay, you
Oh
okay,
yeah,
it's just
We
see
are not choosing
yeah,
here.
we're not choosing actually. We're just seeing how many total numbers.
yes.
So we are
Here,
but we are seeing how many different choice we can make of putting this type of combination into this bin.
correct. So what does that mean is, let's say I wanted to say that, let's say you have one cluster. So I say that you will have at let's say 3 clusters, right? Or maybe let's say take a smaller number. Let's say I wanted to arrange all of these 5 into these 2
Two clusters.
boxes. So what, in how many ways I can do that? So I can have this x1, x2, x3 here, x4, x5
I
here,
see.
right? I can have maybe x1 here and x2, x3, x4, and x5 here. Is that fine? So, is that correct? So,
Okay.
how many such possibilities I am having?
32.
32. Then what does that mean? 2 to the power 5.
Yeah, 2 per 5.
Yes, sir.
Correct, right? So each of this will have 5 options, right?
Mhm.
So I can say that each of it will have 5 options. That means it is 2 to the power 5 options, right? So
Not exactly, but
yeah,
it would be less than
it is correct. It is correct. So, but
and empty bins pure aluminum.
yeah. So you need to subtract that 5, right? Maybe I think 5 or 2. Yeah, I think it's 5. But okay,
Both bins cannot be empty, no?
both bins cannot be empty. But roughly it is 2 to the power 5, right? 32.
Yeah, -2.
Yeah, but then
Each of them can be empty.
if you have 3, yeah, it should be -2, and if you have 3, then you will have 3 to the power 5 possibility. Is that fine?
Okay.
It's okay. It's okay. The numbers are not. That's not the matter here. The thing is, that means as you have like so many possibilities, right? But then you need to see that which one should I choose, right? Or where it will go, right? So this is the correct clustering, or this is the correct clustering? If I see at these numbers, what do you think? Which is the correct clustering? Do you feel that all of these data points are into the correct clusters?
Yes, sir.
Yeah, right. Because you can see that, and how you
They are
decided similar, but similarity. How you define by how you define the similarity?
Similar in its own universe.
It's a distance.
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 Distance is the thing which is we actually are worrying about, right? So what does that mean? These are all data points. They are very close to each other, right? These are all data points. They are close to each other, and these are compared to what? So let's say if I
Cluster data points.
this data point and this data point, right? And let's say if I just see,
So what if the data points are more spread out and scattered?
it's okay, that I will decide later on. So slowly we'll answer to all of the questions, but you understand, right? So this data point is very close to this data point compared to this data point, right? The orange color data point which I have selected here, this is closer to this than this, right? So
Yes.
that means we have to decide where it will go, right? And based on the distance. So for example, I'll just draw a simple image here, or a simple graph here. So Okay, maybe I'll just draw some. Okay, is clear. So let's say this is my x1, this is my x2, this is my x3, this is my x4, this is my x5. Right. So if I ask you what clusters will you select for, okay, if I wanted to have only two clusters, which data points will go into which cluster? These three go into one cluster, and these
Yes.
two will go into another cluster, right? Are these the vectors? So I'll just draw their vectors, right? So I'm just drawing their vectors. Is that fine?
Yes, sir.
And how will you say that all of these go into one cluster? If I because you can see that they are all nearer to each other, right? Distance wise, right? So x1, x2, x3 are uh, close to each other compared to x4 and x5, right? And x4 and
Sir,
x5 are
but how do you draw the boundary that, okay, in that cluster, what if it's little more nuanced
no. I'm just
and
see.
closer?
No. Here it is like I'm just drawing it to understanding purpose, visualization purpose. This is not going to be like this. This you are able to identify because you know it, right? But we do not know how the machine will learn, right? So our goal is what generally in machine learning is to how the machine will learn that, right? So we understood one thing is that there is this metric which we are going to use, right? Correct. Distance is the metric we are going to use when I wanted to uh, like cluster all of these data points. Fine. Okay.
Yes.
In that, what you can say that if I take the mean of this three, right? Let us say that mean is mu1. Okay. So this is the mu1 is the mean for the first cluster and mu2 is the mean for the second cluster. What does that mean? That
And sir, you are, and so the observer is choosing that, you have these x1, x2, x3 in one cluster.
Hmm.
Then what is the point, sir, of the whole thing? If we are only saying that they're choosing what points would be in a cluster.
Correct. So right now it's not making sense, right, for you. You are just saying that, but it will make sense. I'll tell you. So
Okay,
there is an
sorry, yeah.
algorithm. It's okay. So sorry, that's fine. Yeah, that is correct. Like your understanding is correct, but that is how you build algorithms, right? That is how you actually understand. So the core problem is what I wanted my machine to understand like this. So as we are the humans, right? We are able to understand it, but now the machine will understand this. That is going to be, and that too without the supervision of humans, right? You don't want to tell the machines that okay, you just group these 3 points into one cluster and these two other points into one cluster. Is that correct?
Yeah.
Machine should be automatically able to cluster these points. Is that correct?
Correct. And for that one, boundary is needed, right?
Boundary is not needed, but this is like artificial one I have just written.
Okay.
That is just
Got it.
imaginary boundary, no?
Yeah. So it's not.
If they are much spread out, no, then in some subsequent iterations, those will be settled down into the correct clusters.
Yeah. So what I'm saying is that if you have, let's say mu1 is the mean of these clusters, and how would it look like? Mu1 will be what? X1 plus x2 plus x3 by 3, and mu2 will be another cluster which is, let's say, x4 plus x5 by 2. Is that fine? So what we are saying is, if x1 minus mu1, right, this distance, let's say I'll take a square root of this distance because these are the vectors. So we take the square of this distance plus x2 minus mu1 square plus x3 minus mu1 square, right? So if I take the sum of this plus x4 minus mu2 square plus x5 minus mu2 square. This should be what? This entire sum should be what?
Some scalar.
No, it will be smallest or it should be largest.
Should be smaller.
It should be smallest, right?
Mhm.
Because I can have other sums also, right? So like let's say I can have this is what we have achieved, right? So if you are able to achieve this case, that if the sum of all of these distances, right, if it is smaller, right, then I think we able to correctly group of all these clusters, correct?
Yes.
It is possible that I can, and how, in how many ways I can actually write down this sum. There are like very different possibilities to have. But right now let's try to understand that our function here is what. Now my goal is cluster these data points. Now the function is a function of, say, z1 z2 to zn, which is summation of I equals to 1 to n norm of each of this data point minus mu zi. What is zi here? The cluster indicator for that data point, right? So I here is what? So data point, right? Zi is what?
Cluster indicator.
Cluster indicator for ith data point. In this case, what do you?
Sir, when you say it's the smallest, it's smaller than the original, or is it the absolute smallest?
No, it should be like smaller than the previous one. So this clustering algorithm is actually an iterative algorithm, right? So you are iterating it over and over, and you. So I think you guys know about the gradient descent. Gradient descent is one of the iterative algorithms, right?
Yes.
So what do you do there in the gradient descent algorithm? You initialize with some weight vector, right? Let's say, I don't know how you learned it, but let's say it is wt plus 1 equal to wt minus eta del of I think del L, or I don't know what del F I think you used to, and at wt, right? That is what you used to do. So this was an iterative algorithm, right? What you used to do, you initialize with some w0, right? Correct?
Yes, sir.
You will be given some function, right? So function is given as, let's say, f of xy is x square plus y square. You choose the w0 as, let's say, x0, y0, some values, correct? It will be a vector, and then what do you do next? You differentiate this function. It will be
Gradient vector.
dy, and I add so at x0, y0, what is the value? I'll add it here, and I'll find out next w1, right? Then I'll put w1 back here, and like that, right? And you will stop at some point of time, so right,
which is the minimum point.
Correct, and that should be a minimum point or nearest to the minimum, right? Wherever you are stopping, it depends on that. But the understanding we have to take it from this gradient descent algorithm is that it was an iterative algorithm, and similarly this algorithm, right, the clustering, k-means clustering, right, this is also a iterative algorithm. And it is and what is this here? It's a function of cluster indicators, right? What are the values taken by these cluster indicators? So in this figure, what is the value of cluster indicator? So z1, so okay, how many z's are here? Two. Z1 and z2, right? For x1, what is the cluster indicator? Z1, right?
Z1.
X2 is,
or if Z1 is that.
X3 1 Z1, X4 is Z2, and X5 is Z2. Is that fine? These are the data points, and these are their corresponding cluster indicators. All right.
Yes, sir.
I hope it is fine. And what is mu Z1? So mu Z1 is what?
Mean of that cluster.
x1 plus x2 plus x3
x1 plus x2 plus x3 by 3. And what is mu Z2?
x4 plus x5 by
x4
2.
plus x5 by 2, right?
Mhm.
Like that. So what we are saying that it's a function. So this is the function of these cluster indicators, correct? And here each of mu z I, right? Or I can say that, let's say I will say that zi equal to k, right? For the kth cluster, right? It is equal to summation of I equal to 1 to n, that each xi, and there is one indicator, cluster indicator for zi equal to k, and divided by summation of I equal to 1 to n, cluster indicator for zi equal
So once you're done with the formula, could you spend some time just explaining this formula?
Yes, definitely. Yeah. So this is the formula, right? So cluster indicator. Have you studied cluster indicator function previously? I think it was there in MLF week 1. Uh, so what is the cluster indicator, or not cluster indicator? What is the indicator function?
Was it that sign of something is equal to positive, negative?
Yeah. So indicator function is that if anything inside that function, right? If it is true, it will say 1. If it is false, it will become 0. Fine.
It is density estimation, I think.
No, not density
No,
estimation.
classification.
See,
Binary classification.
no, it's a mathematical tool, right? So it's a cluster. This is what density estimation. Okay, that is.
Sir, it is in binary classification.
No.
No,
Yes, sir,
no,
but
I think
like it's an indicator function that does this following act.
Plastic.
Indicator system is what?
Mathematical tool like Boolean.
Yeah, it is kind of a function which gives me 1 if, let's say, it will give 1 when z equal to k, right? It will give 0 if it is not equal, right? So whatever the condition inside here, if it is not true, right, it will give me 1 and it will not give me. So let's say I'll show you by using the example. I think then it will be understandable. In the previous example, we have x1, x2, x3 into cluster 1 and x4 and x5 into cluster 2. Is that correct?
Yes,
Fine.
sir.
So this was in 1 and this was in 2. So let's say if I wanted to find out mu 2, right? So here k equal to what? 2. Okay.
Yes, sir.
And then what? How this numerator will look like? So let's say it is a summation of along this all 5 points, right? Correct. So if I take x1 here into the indicator function, so zi
Got it, sir.
zi equal to 2 or 1. So this is into 1. So what is the z1 here? This z1, this z1, z1, z2, and this z2. Sorry, z2. Huh?
Sir,
Yes.
in the lectures, no, sir, taken like Z1, Z2 to Zn, but the indicator function for the ith data point, and then they will be assigned with the like Zi will be assigned with the cluster.
Correct. Right.
So
here let's say Z2. Okay, correct. So Z3, that is fine. Okay. So in this way it is Z3, Z4, and Z5. Right. So this is a cluster indicator for that point, right? Data point, and it can. So Z1 can take values now 1 and 2, right? Sorry, not Z1. It's Zi. Correct. Because this data point either go into cluster 1 or it either goes into cluster 2, right? Is that okay?
yeah.
All of you are fine with this? So maybe I'll just rewrite all of this again if you don't understand.
It's fine.
So yeah, this you have x1, you have x2, you have x3, you have x4, and these are the 5 data points you are having. And the cluster indicator related to the data 1 is z1. Cluster indicator here it is z2, is z3, z4, and here it is z5, right? Z1 can be 1 or it can be 2, right? In our case, because we have only 2 clusters here, right? So if it is there, if it is like that, then so and each of this zi, right? So each of this zi can take either the value 1 or 2. Correct?
Yeah.
If I have mu2, then it will be x1 into if I go with this formula, so z1, either z1 equal to k is what? What is the value of k? 2. So is z1 equal to 2?
Sir, you haven't assigned the clusters.
No, we have assigned it, right? It's the same previous example. So I'm just saying that x1, x2, x3 it in cluster 1
Okay. Okay.
is 1 and this is 2, cluster 2, right? So now can you tell me z1 equal to 2 or 1?
1.
So
1.
so that means this indicator function of this will give me what? 0 or 1?
0.
0.
Because if it is not true, that means it will give me 0. So x1 into 0 plus x2 into what?
Zero.
z2 equal to, so again 0 plus x3 into 0
Zero.
plus x4 into
1.
1 plus x5 into 1, right? That is your numerator. What about the denominator? So z1 equal to 1? No, right? So it is 0 plus 0 plus 0 plus 1 plus 1. So if I just do it, it is x4 plus x5 by 2, right? And that is what we have already written previously, right? That was your mean, right? So to show this mean in a different fashion here, is that okay?
Yes, sir.
Got it.
Yes. Yes, sir.
So I will write it again now. So what is our function now? To have so it is a function of cluster indicators, so that so you wanted to uh, have all of these cluster indicators in terms of what? The distances, right?
Yes, sir.
Distances from each cluster mean should be what? It should be minimum, right? So it should be xi minus mu zi norm square. So this distance between each of the cluster from the data point, right? So from that mean, it should be as small as possible. That is my goal. And here, each mu k is equal to summation of I equal to 1 to n xi indicator function of zi equal to k divided by summation of I equal to 1 to n cluster indicator of zi equal to k. So this is what it is there. Now this is my function right now. I need to minimize this function, but as I said, this clustering algorithm, right? So Lloyd's algorithm, it calls as Lloyd's algorithm or K-means algorithm. It's an iterative algorithm. What does that mean? We wanted to initialize something first. So what you are going to initialize first? So we are going to see now the Lloyd's algorithm or K-means algorithm, right? Here, what you are trying to, so first thing is what? In any iterative algorithm, we do initialization. Fine. So what you do is you initialize all the cluster centers randomly. And how many it can be? It can go up to, for all data points, you just
So can you explain this Z1 and superscript 0? What does it
superscript
mean?
0 is the iteration.
Okay, so you're making each component, like each class, each Zi as 0 as the initial value.
You can take any random value. I'm saying
Okay.
that it could be any random initialization.
But you're taking here as 0, right? That's why this is 0.
No, 0th iteration, initial.
Okay, 0th iteration, sorry. Yeah. Okay.
So it's iteration, right? So I have written at so the superscript
Then how
is,
many need to be iteration?
Yeah, that is what, like how many and when to stop, right? So that is the next question. But
Yes.
can you think that okay, each of this z1 will take values at what, 1 to k, right?
Till there's some converge.
No, converge is fine, but this means I need to define this k first, right? K is what?
Number of clusters.
Number of clusters. So each of this value we have randomly assigned, and it will take values between what, 1 to k. For example, let us say you have this data point x1, x2, x3, x4, x5, and x6, 6 data points, and I wanted to have 3 clusters. So that means, and I have this assignment, initial assignment as like this. So z1 naught is equal to 3. z2 naught corresponding to this data point, the cluster indicator initially is 1. z3 naught is equals to 3. z4 naught equals to 2. z5 naught equals to 2. z6 naught equals to 2. Is that understood?
Why it is more than, why it not more than 3? We can
Because
take it to 6 now.
no, we can do 6 also. That okay, the how we choose the k, that is also the question which we need to answer. But right now, just think that okay, I need only 3, right? So here, right, do you I can do 5 also, right? 5 clusters I can do, right, for these 5 data points.
Yes, sir.
But we thought this is the better one, right? Like 3 going into 1 and 2 going into 2, right? So here I think the 2 is enough, right? If I have 5, will I get any information out of it?
No, sir.
No, right? So that means it's like kind of same whatever was there previously, all data points. There is no use of it. So you should, so see, whatever you are trying to do, you should be able to get some information out of it. So now if you
So
do this clustering, like if I have 2 clusters, right, enough, then I'll get, if I have only 1 cluster, will that work? That means all data points, all 5 data points into 1.
sir, is there a
No,
mathematical
no.
way to define how to break into clusters, how many clusters we need?
Yeah, it is there. It is there. The choice of k is there.
Okay.
Right. So, but for now, you just think that I need only k equal to 3, and k equal to 3 gives me better clusters. Fine. Uh, so this way the assignment will happen. Do you understand the assignment?
Yeah.
Right. So you understand what is this z1 of z1 naught means what? This is z1 is what, corresponding to the cluster indicator corresponding to the data point 1, which is x1, and 0 is the iteration. So it may change to 0. Z1 of 1 may goes to 1 2.
Sir, so this Zi and superscript, it's a numeric value, right? Now, wouldn't this numeric value have to be close to x1?
No. That is cluster indicator. What does that mean? So it can actually take the finite values only, right? It can go for k equal to 1, k equal to 2, and k. So z1 can take only 1, 2, and 3, right? That is what it is written here, right? It can see x1. It's not x1. It is the indicator of cluster. So like, is it going to the cluster 1 or cluster 2 or cluster 3? That is what it is indicating right here, right? So what does that mean? X1 goes to the cluster 3. X2 goes to the cluster 1. 3 goes to the cluster 3. And that is what we randomly select these clusters for these data points. Fine. This data point will have there. So each of these data point is in RD, D dimensions. Right? They are like vectors of D dimensions. I am just putting them into 3 clusters. And this says that this first data point goes into the third cluster, the second data point goes into the first cluster, the third data point goes into the third cluster, like that. And this is what I have randomly initialized now, right? And after one iteration, maybe the cluster change, right? So that means x1 data point goes to the second cluster, x2 remains into the first cluster, x3 goes to a first cluster after, right? And
After one iteration. Yeah.
like this.
And what is this iteration, sir?
Iterations I'll define. Yeah.
Yeah, I like, so there's some formula like how gradient descent that we come down to
Yes.
from, yeah. Okay.
Yeah. So in gradient descent, what you used to do is you just so you have these functions, right? And you need to reduce that function, right? Here in this case, what is your function?
F of Zi.
So we wanted
And
to minimize the distance between the data point
each
and the
point.
cluster centers, right?
Hmm.
Correct. Or centroids, cluster centroids or centers, whatever you can call it as called. So this was my, right? This is my function. This is my objective function here, right?
Hmm.
This is the objective function which I need to
Minimize.
Right? And what does it do? It is actually, so I need to find out that function which will reduce the distance between each data point
and its mean.
and its mean, right? So let us say I'm just drawing here, like I'll draw one graph, or maybe, right? So you try to understand it in a way and tell me, right? So I'm just writing it randomly. Okay, maybe I'll just do one thing. I will not make too complex. I'll just make it simpler. So this is, let's say, data point 1, this 2, this is your data point 3, this is your data point 4, and this is your data point 5, right? So x1 corresponding z1 is, let's say, 1. So I have k equal to 2, suppose. Fine. So that means each of zi will take how many values? 2 values.
Yes, sir.
So I'm just indicating z1 equal to 1, z2 equal to 1, z3 equal to 1, z4 equal to 2, and z5 equal to 2. This is my initial. So initially I have randomly assigned these values to the data points. I hope you understand what is that now. What are these values now? What does that mean?
So, but in the algorithm, we won't assign the clusters, but we will choose random data points, right, as centroids.
Yes, but then based on that you assign these values to them, right?
Yes, understood. Okay.
Correct, right? So initially you need to give, like, put this data points into one cluster, then only you'll get the centroid, right?
Yes.
So
And that also, the algorithm will only calculate the distance between those centroids and the data points.
Yeah, so you don't give the centroids basically. What you do is you put centroids first. No, sorry, you put the cluster indicators first, and then you calculate. I'll tell you how it will be done. So for this initial thing, these are all 3 points into one bucket, right? This is cluster 1.
Yes, sir.
And this is your cluster 2. Correct. Fine. This is my initialization right now. Okay. So what will you do here in this case? You calculate mu1. What is mu1? Mu1, let's say in the first iteration. Mu1 is what?
X1.
X1 plus
x2
plus
3
upon
divided by 3.
Okay, so sorry, it is 0th iteration, right? So
Hmm.
initially only this is what it is. And if you look at this carefully, I think it will somewhere it will be here, right? mu1, or maybe not here, maybe here, because it will draw like more towards x1 x2, right? Because they are like contributing much here. So let us say it is mu1. Is that fine?
Yes, sir.
Okay, what about mu2 not? It is
x4 plus x5 upon 2 divided by 2.
Is that okay? And let's say, suppose it is somewhere here, and I think it is the fair choice of it, right? Okay, so this is my first iteration or 0th iteration, or that means like random initialization. What does you do next? What you do is, now these were the initial randomly chosen cluster centers. Now I need to see that whether these cluster centers will remain the same when, what do you do? What is your function, objective function here? Let's say, okay, I'll just write down exact way. So f of z1 comma z2 is equal to the distance between x1 minus
mu1
square. Okay, maybe I'll just write down the formula later on. We'll try to understand it first. What is exactly it is saying? So it will calculate, let's say, the distance between x1 minus mu1 square, right? Fine. Okay.
Yes, sir.
And let's say x2 minus mu2 square. So x1 will go to which cluster center?
1.
Why? Because the distance here, right, between this and this, right? Which one is better? This is larger. Oh, I have done it wrongly. It is x1. For the same data point, I'm just talking about to understanding purpose. Is that okay?
Yes, now it makes sense.
This is fine. So that
Yeah.
means the cluster indicator for x1 in the first iteration should be 1 on
Sir,
1.
sir,
Yes, sir.
shouldn't it be norm squared?
It's okay. It's okay. I'm just trying to say that yeah, that is your correct.
Here we are just
Trying to understand. So that's why I'm not writing all the notations, but you just
So
think
this algorithm is going to compare each and then give that in like
correct.
which.
So next time what it will do? It will check the distance of x2 and mu1 and x2 and mu2, and what do you think which will be the greater one? So z2 of let's say the first iteration is equal to
1.
1. What about this data point? It will calculate the distance between this and this. So what will happen to x3?
It would be 2.
x3 minus square and x3 minus mu2, the length of this. Which one is greater? This one, right? So what will happen here? It will change z3 in the first iteration to
2.
2. What will happen to z4 in the first iteration?
It also 2.
2, because the distance between this and this is much smaller than the distance from the first centroid, and z5 in the first iteration is going to be 2. So what will be so after one iteration, what will happen here? After one iteration, so x1, x2 will go into one cluster, and x3, x4, and x5 going to be the second cluster. Okay. So next time what will happen? Again, it will check. So what will the next part? Then mu1 will become x1 plus x2 by 2, and mu2 will become x3 plus x4 plus x5 by 3. Is that fine?
Yes, sir.
So sir, mu and z will keep changing until it gets to some optimal scene.
Yeah. Yes. Right. So okay, I'll just remove this part. And
there is no optimal solution you can get.
There is optimal solution. So,
but K-means won't give optimal solution. No?
Yeah, I'll tell you what is that.
Converge, but
it
will converge and it will give some reasonable clusters, but there is no optimal solution.
But it can be optimal also, right? Why not? It can.
It will tend to optimal solution.
Yeah. So you can't say that it cannot give, but it is. We can't guarantee it, right?
So there's something better than K-means.
Actually,
that is giving better solution.
No. It's actually not algorithm is better. You know that there is a possibility, right? That it will give there is some optimal thing, right? So that is what it is. Okay, I'll tell you what is exactly the. So those who have watched the lectures, they might know. And if it is not also, it's fine. It's not a big deal about it. So what will happen now? The cluster has changed. So I'm just drawing the clusters. So this again. So this was initial clusters, right? What happened now? This has become one cluster, right? The red one, and
Yes, sir.
it's going to be this another cluster. So the mu will change for this. So mu2 is going to be this one, mu2 after the first iteration, and mu1 may be here, right? So what do you think? After this, this is going to be settled down here, right?
Yes.
So how does it know when to stop? Like yeah, this would be the minimum between all. So
Yeah.
okay.
When there is no jumping.
Right.
Hmm.
Right. So that means
After two iteration are same.
yeah. So that means if you are not able to find, let's say in terms of this f of z1, z2, z3, z4, and z5, right? If the value in the let's say t plus a 1th iteration, right? Is that fine? I think you are able to understand this. If it is become equal to f of say equal to, or maybe you can say that what is it? Can you say that equal to or less than equal to?
It
Or
would
should
be,
be
I
less than or
think,
equal to
exact equal to.
Z1T.
Yeah. So it will keep
Less than, I think.
Less than.
Less
Yeah,
than.
less than or equal to.
less than or equal to is fine. So this is going to be if zt z2t and up to z5t, right? So if this happens, then so that means what does that mean? That after finite number of iterations, we are able to reach to the solution, right?
Hmm.
So I hope you understand this part, right? So
So if it is equal to,
equal
then
to is
we,
fine. Equal to is fine, right? That means it is fine. So this whatever it happened here, right? That is going to be the same. So that cluster center also is fine. Correct, right? So what is our algorithm now? I'll just write down the algorithm. So what you do first? You do initialization, correct? Initialization for all data points.
Sir, is inequality written true like right, or it may be opposite of that?
No, I don't understand the question. What is your question?
This equal greater than equal to sign is like opposite, or it would be
No,
the
this is correct.
same? Like,
No, this is correct. That means the t plus a 1th iteration, right? This is the iteration here, right?
t plus one iteration, the value of that is less than the t
Yeah,
iteration.
because what is your objective? What is your goal? This function has to be minimum, right?
Then what is the guarantee that t plus two iteration not be the less than that?
Final should be minimized. I
Oh, okay. This is what this is the convergence actually. Is what it is saying that okay, if it will happen, right, we'll stop. So okay, so
That
okay.
the question is, but
Yeah,
how
yeah, correct.
many times?
So yeah, once it happens like this, let's say, then you should stop
Uh,
at 8th iteration. That's what
yes,
the
yes.
stopping point.
That's why. That's
That's
why.
correct. That's correct. What we are saying here is this should happen each iteration. Correct. When it will get converged? When this happens. This is the convergence, right? Is that correct? So
no.
this is going to be the convergence here, right? So what does that mean? Each of the iteration, either this value should be equal to this, the previous thing, or less than this. If it becomes greater, that means it's not the optimal one, right?
Sir. Yes.
Yes, sir.
Right. So, and that is what the convergence criteria. So you run this algorithm until what? Until the convergence. And what is our first step? So at each of the step, each of the iteration, right? What do? First you compute means, right? You compute means. Compute means. And how do you compute the means here? For
That formula.
yeah, for every k. For every k means what? What is k here? What is
Cluster.
Number
Cluster.
of pins.
number of clusters, right? Compute means for every k. So that means if you have k equal to 3, then that means how many means you are going to calculate, or centroids you are going to calculate? 3. I hope it is clear. So mu k is equals to summation of I equal to 1 to n xi, and it's the cluster indicator of zi in the tth iteration equal to k divided by summation of I equal to 1 to n, the cluster indicator of zi, the tth iteration. Is it fine? This is how we have seen also this formula. What is the next step now in this? So you reassign, right? When you reassign, so for each of this data point, when you reassign,
When the distance between is
that
lesser
means, yeah,
than the
yeah,
previous iteration.
correct. So you just do it when you, this is like, okay, the cluster center is going to change, right? Basically, and the cluster center is going to change when the distance between that current point and each of these cluster centers, right, is going to be the minimum. Is that fine? That minimum is you are like arguing for this, or this is the argument for the minimum value of this k, correct, right? Let's say for this x1, if you have mu1, mu2, mu3, what do? You find out the distance between x1 minus mu1 square, x2 minus mu2 square, and
So could you also just do a question after this, just showing all these points?
questions.
So,
I think we will do it in the solve with us, right? So
no,
it's fine.
not just a basic question with some points, so that okay, this makes.
You have done,
like,
right? You don't understand that?
Sorry.
You didn't understand the previously when
No, I understood. I just wanted to be solidified.
It's the same, man. Like, okay, we'll see
Okay.
that. It depends on like.
No, like in this argument part, that's where I thought like.
No, that's what I'm actually showing you here. What is that argument part? So this is x1, right? And if you have k equal to 3 clusters, what does that mean? You have mu1, mu2, and mu3. Three centroids at, let's say, tth time step or tth iteration. Is that correct? What you do?
Yes,
you
sir.
find out this, the distance between that data point and the this, right? Mu1 t, x1 and mu2 t, x1 and mu2 3. Is that fine? And what do? Whichever is the
Minimum.
right. Suppose if this is minimum among this, then what this argument it says that if this value is minimum, then you choose the k is equal to what now? 3, right?
3.
So z.
Okay, so it's a choosing thing. Like you have to actually calculate each thing and then choose.
So zi in the z1 for t plus 1 iteration is going to be 3. So you are minimizing this part, right? You are choosing whatever the minimum is there, and what does that argument gives you? The value of k, corresponding k. So what is the k value here? It's 3. You understand?
Sir, we are minimizing in each iteration. Yes, sir.
So reassignment, when it will be like reassignment happens. So how do you give the, okay? Let us, okay. So okay, I'll just maybe you understand. Okay, this formula you have seen it, right? Can you just remember this formula? What is it? We'll try to see for, let's say, for some numbers possibly. Is that okay? I will take the simple example. Let's say x1 equals to maybe 10, x2 equal to 12, x3 equal to, let's put it as 1, x4 equal to 2, and x5 equal to 3. Is that okay? These are the data points in one
Yes, sir.
dimension. Fine. Let's say z1 equals to, and I'm going for k equal to 2. Okay. So z1 naught is going to be, let's say, 1. z2 naught is going to be 2. z3 naught is equals to, let's say, 1. z4 naught equals to 1, and z5 naught equals to 2. Is that okay? This is like randomly assigned. Fine. Is that
Yes, sir.
okay? What do you
Yes,
do
sir.
now? What is your step now? You choose
Compute the mean.
mu. So how many means you are going to choose? So mu k, right?
2.
So k is going to be equal to 1 and 2.
2.
So mu naught k, mu naught 1 is going to be
10
10 plus
1
1
plus 1
plus
plus 2 plus 2
plus 2.
2
Right? So 1, 2, and 3. Right?
Yeah.
Yeah.
Divided by 3.
3.
That is going to be what? 13
13
by.
by 3.
So I don't know.
4.7.
Yeah, we'll leave it like that only.
Okay. And then
Yeah.
mu2 naught is going to be 12 plus
3.
by 2. So it is going to be 15 by 2. Fine.
Yes, sir.
Okay. So okay, maybe can I just do some changes here?
Yeah.
If I can, because I
We
think it will be good if I have this round number, right? So
can change 2 to 5.
2 to
x4.
4. That will be 0 by 3, sir. 2
this is
by
going to be fine. This is going to be fine. So
x4 we can make 5.
5 then also it will not work, right? It should be the
4.
maybe I take
Replace 2 by 1. Replace 1 by
6.
2.
2 by 6. Then it
okay.
is 7, 7, 7, sir. Then it will be 18, na?
Then no, but then 7 will be very close to then 10 and 12, and that kind of thing will happen. I don't want that to happen, right? So it's okay.
10 with 9.
It's okay. It's okay. Leave it. 10 with 9, huh? That would be a good.
10 with 0.
Yeah, 10 with 9 is going.
10 with 0, sir.
10 with the zeros is fine, but okay, 9. I think this is good for this, because then 9 plus 1 to 12, right? This is going to be 4, right? And this is going to be let's say 7.5. Is that fine? Okay, this is good. Okay, so what you do then? You wanted to find this thing, right? So I for, let's say, z1 in the t plus 1 iteration is going to be 1, right? Is going to be the argmin, right? For that k, where I will have x1 minus mu k square, right? This is what it is, right?
Yes, sir.
Correct. So can you tell me what is this? What is it? What it is saying? It's saying that x. So I need to. So how many k's are there?
2.
2 case.
1 and 2.
And in the tth iteration, so one is going to be t plus 1th iteration, and 0 is going to be the tth iteration. Now if you see that, it's going to be 9 minus the distance between 9 minus 4 square, right?
Yes, sir. Yes, sir.
And the distance between 9 minus 7.5 square, right? So which is the minimum distance among these two?
Second.
So can I say that it is oh sorry, I'll just write down here. So it's going to be okay, going to be greater. This is getting hang.
First is greater than second.
I think it's hanging.
Yeah, I know. This will happen sometimes. It's okay. So, but it is greater than 9 minus 7.5 square. Is that okay?
Yes, sir. Yes, sir.
So that means this is the minimum distance is going to be minimum. But what is arg minimum is saying that I should. So what will be the value of this?
2.
Going to be 2. So I'll choose k equal to 2, because for k equal to 2, for k equal to this is going to be the minimum value of the function. Understand?
Yes, sir.
right? Then what it will do, z2 of 1 is going to be r min k, distance between x2 minus mu k
1K.
naught. Is it okay?
Sorry, yeah.
And now what do you do the next? x2 is what? 12. So it will do 12 minus 4 square, and then 12 minus 7.5 square. Again, what it is indicating me is going to be
Second.
13. So my k equal to 2 here. So what are the first iteration? What will happen? What are the reassignments happening? Z1 of 1 equals to
2.
Z2 of 2
2.
equals, sorry, Z2 of 1 equal to 2.
2.
Z3 of 1 equal to, because it is going to be nearer to this 4, so I think it is going to be 1. Z3 of 2 is going to be, I think it's 1, and Z4 of 1. Sorry, I'm getting like, sorry, wrong notations. That Z4 of 1 is going to be 1, Z5 of 1 is going to be 1. Is that fine?
Yes, sir.
And what do you do next now? You take the mean of this, right? So the next step, mu2, sorry, mu1 of, in the second iteration, is going to be this one, right? This point, 1 plus 2 plus 3 by 3. Is that correct? 1, 1, 1, corresponding to this point, and this points. And what is mu2 of 2? It's again, so it's kind of like that. I hope you understand this now. It's getting messy here. So, but
So it'll be 9 plus 12 by 2.
yeah. So and then it will again, what will it will do? It will go and do this
So
calculation.
it'll reassign again.
Yeah.
And just keep opening.
Yeah.
So you'll find the best K basically.
Yeah, that's what it is, right? That is what it is saying. So that algorithm is, I hope the algorithm is clear to all of you.
Sir, we are repeating same again for previous step.
Correct. So I'll just show it is, maybe it is there in this. It will be like much clearer, or not messier, right? Whatever I have written. So so this was your step, right? Do you understand this algorithm now?
Yes, sir.
Yes, sir.
Very clear? Okay.
Yes, sir.
Okay. So now the next problem is what? I need to see that whether they are, this algorithm is there, it's fine, but is it going to converge or not, right? And then the clusters which is going, it is going to produce, will, the nature of clusters is, or what kind of clusters it's going to be produced, and what initialization I should choose, and what should be the choice of key, right? So somebody has asked, so initialization, maybe I'll discuss it later, but someone has asked me, what is the choice of key, right? I can have k equal to 1, k equal to 2, k equal to 3, k equal to 4, and k equal to 5, right? All 5 I can choose, but why should I choose only 2, or why should I choose only 3, right? How should I choose the
Number of clusters?
Yeah, how many number of clusters are there? And before that, I need to see that whether it's going to converge or not. Is that correct?
Yes, sir.
These are the questions we are having. Just give me a 2 minutes. We'll take a break of 2 minutes, and then we'll come back. Is that fine?
Yep.
Yes, sir.
So we'll take like maybe 20 minutes to finish this off, and then maybe I'll take that 2 questions from the grid assignment, and we'll close.
Got it.
Okay. So yeah, let us try to understand what is. Am I audible?
Yes, sir.
So when do you think that it's going to get converged? We have discussed, right? This is the
When
function.
the distance is
Yeah. So
the
when
next
this will happen,
iteration does not give a lesser distance between the
yeah,
points.
yeah. So if this, right, the distance between this, so whenever you are not able to get the clusters, right, such that it will be having like minimum distance from the previous clusters, right, then at that point, so that means reassignment is not going to get happen, right?
Hmm.
If it is not happening, that means what? And how it is reassigning based on this, right? Based on these distances. If this does not happen, then it will not converge. Is that correct? But the thing is it going to get converged, right? So that is what it says. But okay, maybe I'll not write down all the things. It is already there in the lectures. Can we just understand this? What is this meaning is? Whatever it is shown here, what does that mean? If you have, let's say, five points, right? Can we be able to get any point or any point such that or what will be the point which gives me the minimum distances for all from all these points? Okay, what does that mean? Okay, let me define it. Let's say if you have 5, 2, 3, 1, and let's say 0. These are the 5 points I'm having. Is that okay? Let's say
Yes, sir.
each of these one dimensional data is there, x1, x3, x4, and x5. Can I get this one? So the argmin, right, from each data point? Can I get, let's say this is some v, right? Can I get some v such that the distances of all these points is the minimum one? What point will that be?
The mean, right?
The
Not the
mean,
mean, but
right? Yeah.
oh,
So yeah, so it will be like 5 plus 2 plus 3 plus 1 plus 0 by 5, which is 11 by 5, right? So 11 by 5 is how much? It is 5 is 2.5. 2 point, not 5, 2.05, I guess. 2 point, 2, right? 2.2.
5.2, no, sir. Oh, sorry. Yeah. 2.2.
2.2, right? So 2.2 is that point uh, from which all of these data points are at the same distance, right? Or that the minimum distance, right? You can think of in that way. So that means I'm able to find for all data points a point such that, and what is that point basically, which will give the minimum distance? It's going to be the mean, right? So if I wanted to find this one, right? Correct. So that means the answer to that is like I'm going to get that mean. So if you have bunch
Correct.
of data points, right? Can we get uh, the means, or can we get those points such that
Ritik, unmute, please.
unmute or mute? Okay, fine. So that's okay. So the understanding here is if you are going through the iterations, right here.
So can you go slow? We'll go slide by slide quickly, like.
Okay, maybe okay. So if it is not understandable, then I can write it down. But let me. So okay, here. This one is fine. This one I think you will be able to understand.
From the
So
last point you mentioned was we find the mean, which is the optimal point between a bunch of data points,
correct. So
which has
that
the
is,
least distance.
yeah. So it's just going to be the point, right? You are going to have that point, which is so. Okay, maybe I'll just try to discuss it here, and then we can see, because the slides, the notations are there. Otherwise, you will understand it better. Okay, maybe just see some numbers. Right? So let's say 5, 2, 1, 0, and again 3. Right? Fine. These are my data points: x1, x2, x3, x4, x5. I need to choose that point from which the distances are going to be from each data point is going to be the minimum one. Is that okay? Now let's say I choose a point x, maybe let's say v1, right? V1 is going to be 5. What will happen to the distances? So 5 minus 5 is going to be 0, right? 5 minus 2 is going to be
3,
3, 4,
4,
5,
5,
and 2.
2.
Okay, I'm just talking about the distance, okay, purely distance. So you don't tell me like, so don't think it as negative and all, just like that only, right? Then I have V2 equals to let's say 2. Then what will be the distance here? And I'm just talk about the sum of these distances. What is going to be the sum here?
14, 14.
If
So
it is,
how is V1 5?
I'm just taking it randomly. I'm just
Okay.
saying that V1 equal to 5. Now let's say V2 equals to 2. I take some other random point which is V2 equals to 2. What are the distances then?
3,
3,
0, 0,
0,
1,
1, 2,
2,
1.
1,
So it's going to be
7.
7. Let's say you tell me any other point, maybe in between here or in maybe outside of
Minus
this.
4.
Huh?
2.2.
Minus 4.
No, don't take minus. Okay, this maybe see, you know that there is a point which will give. Okay, this is going to be the sum of distances, right? You tell me that point.
4, 4.
Is going to
So
be
2.2, like the mean,
2.2 is fine.
you'll get to.
Yeah,
4.
maybe 4, right? Okay, out of like, because we wanted that point which is going to give me the minimum distance from these points. Fine, right? So if I take V3 equals to 4, what will happen here? 1,
1,
2,
2, 3,
3,
4,
4.
1.
So what is going to be the sum?
11.
11, right? So that means, and now I wanted that point which give me this sum should be minimum,
Minimum.
right?
V2.
And what is going to be that point? So here maybe if I choose let's say 2.2, which is going to be the mean of these points, okay? So what's going to be the distances here? 2.2, 5 minus 2.2, how much it is?
2.8,
2.8.
0.2, 1.2, 2.2, 0.8.
Huh?
0.8.
0.8.
So how much it is going to be the sum? This is going to be 1,
Greater than 7.
be 4, and it's going to be is it going to be
7.2.
7.2?
7.2.
But I think
V2 is minimum.
correctly. Yeah. Okay, okay. What is that? 5 plus 2 plus 1 plus 0 plus 3 divided by 5. What is the mean?
2.2.
2.2.
Did we calculate it correctly then? Okay. Okay, because it shouldn't be like this, right? Basically, see, the thing is, what I wanted to show it to you is that there is a point which is mean, right? Which gives me the minimum value of this, if any data set is there. But are we calculating it correctly here? Maybe I think we should take this one, square of this, right? Because now you tell me. What is going to be this? 9 plus 16. Can anybody calculate? If you have the calculator, can you just calculate properly with all this? Maybe you don't need to calculate this, because this is going to be like higher one, like 1, 2, and 3 point.
54.
54 for the first. Okay.
Yes, sir.
Okay. Sorry. I think I think where we have missed it is like we'll have to take the square of the distances, right? Because it's going to be the distance and square root of it. So that way,
4 to 15 होगा, is equal to 2.
0.2 square plus 1.2 square plus 2.2 square 0.8 square. This is going to be 14.8.
V1 is
Is it 9 plus 4?
15.
15.
Now you just see that, and I think if you check for this also, it's going to be 9, 16 plus 9, 25, 25 plus 4, 29, 29, 31.
31.
So there is a point which is the mean, right? So Mean is the point which gives me what? The minimum of the sum of distances, right?
Average
Correct.
distance between.
So that is what it is saying here. So when I have the bunch of data points, there exists a point which is what mean, right? Which gives me what? The sum of distances as the minimum one, right? Is that okay? This is fine? This all we know?
Yes, sir.
Yes, sir.
So next, how we are going to utilize this in the Lloyd's algorithm, right? So we have this assignments. Like this is the correct assignment at the timestamp t, right? Z1 t, Z2 t, and Zn t, and each of this Zi is belonging to this clusters, right? And then I think all of you know this algorithm right now. You do what?
Okay. Mhm.
You do you just find out the.
It's exactly. Is this what we just did now?
Yeah, that's correct. So that's just what we have done previously, not right now.
Yeah,
Previously.
in that whole the convert coming to
Correct.
like checking if argmin one.
Yes, right. So now we are seeing that for the tth iteration. Okay, now okay, maybe I'll just. So what is the difference here? I wanted to tell you is that these are going to be the updates, right? T plus 1 is what? T is what? The update in the tth iteration.
Iteration.
Right? Tth iteration. Mu kt is what? Is
The mean of
Mean after kth iteration.
And Z1 T plus 1 is what?
updated, right? Yeah.
Updated cluster centers, right? Right? Okay. And now what is this quantity here?
The current one.
Just
Sorry,
check.
this is the next one, the updated one.
And here. So the mu in
the mean of the.
You are understanding this part? No. So now there is a difference here. You read it. What is it meaning? It is saying mean of the cluster.
Explain this.
Yeah. So what is it here? Mean of the cluster where xi wants to go to, right? And what is this? Mu z I t plus t of t. It's mean of the current cluster where xi is assigned to. So if this is going to be the less, right? This is going to be the lesser, right? Then we are saying that it's going to be. I think it's. Where I need to tell you. Okay. So I need you to tell you what does that mean. Fine. These are the quantities, right? Xi minus mu zi t plus 1 of t, this quantity, right? And this quantity xi minus mu zi t. What is the difference between these two? We need to understand, right? So suppose there is one point x1, right? Right? And
yes, sir.
Suppose Z1 is the cluster center associated with it. Maybe can we take the previous some examples so that we can understand better? Yeah. Do you remember this one? What are these cluster centers? 1, 2. This is going to be the cluster center, right?
Yeah, initialized cluster centers.
So mu1 of naught, mu1 of 0 is equal to 4, right?
Yeah.
Right. And in that case, which are the points? The points were x1, x3, right? Let's say, and what was the x4, right? Fine. Now in the second iteration, what happened is this point where it went in the second iteration, cluster 1. Okay, it was okay, same cluster, right? Where the reassignment happened, I need to check. Okay, this one. Just focus on this point. What happened to this point? Initially, it was
got reassigned. And
reassigned.
Z5 also, yeah.
Correct. So here in this case, x1 is what?
9.
It's going to be 9, right? Z1 of 0 is going to be 1. And Z1 of 1 equal to 2. Mu, let's say Z1 of 0 of the 0th iteration, right?
Yeah.
What is that? Which one is that?
4. 4.
Huh?
4.
4, right? It's going to be 4. And now mu z1 of 1 of the 0th cluster, right? So that the time step is equal to what?
It's, I think we calculated below.
This is what it is written, right? So zi t plus 1 of this thing.
If you scroll, sir, I think we calculated it. Yeah, 7.5.
7.5 is what? Yeah. So it's
Oh, no.
correct. What is z1 of 1? What is it? 2, right? So what I'm trying to say here, it is mu 2 of 0, right? Correct, na? Z1 of 1 is equal to 2, and then that is going to be this one, right? 7.5. So if you look at this expression, what it is saying, xi minus this thing, what is that? So it is going to be 9 minus 4 the square, and 9 minus what? 7.5. So that point wanted to go to the this cluster, right? To second cluster. And this is what the distance. So this distance is greater than this, or which one?
Lesser than.
Is greater, right? Than this. This is where the point wants to go, right? The second cluster. This is what currently it is assigned to. You understand that difference? So this quantity is what? The sum along all the points where currently whatever the cluster centers are assigned. This is what after the reassignment, where the cluster wants to go, like, or that the points wants to go, that distance and this distance. So it has to be what? Strictly lesser, right?
Only then we can continue with the iteration.
Correct. That that means we're going to continue with that. Now, what about this quantity? This quantities you understood? This two. Now there is one more quantity which is t plus 1, mu t plus 1, and this. So is there any difference there? So okay, I think it is messy, but still we'll try to understand through this. Maybe I'll just again use some other green color. So this was what? This was mu z what? Z here, let's say t and mu t, right? Zi. Fine. This was mu z I t plus 1 of 0, right? Correct. And there is another quantity which is, let's say, mu z1 of, say, t plus 1 and mu t plus 1. What is going to be mu t plus 1 in this case? Have you calculated somewhere? Yeah. Fine. You were able to understand, or shall I rewrite it again somewhere?
Yes, sir, rewrite it again.
Can you just take the numbers here? Can anybody write it down fast? Okay, 9, 12, 1, 2, 3. 9, 12, 1, 2, 3.
So basically what you are doing?
I'm trying to show that whether it's going to converge or not, right?
Thanks, sir. Like I really appreciate it personally, like, because it's getting clearer and clearer.
Okay, so yeah, x1, x2, x3, x4, and x5. Fine. What were the initial clusters? Z1 not, Z2 not, Z3 not, Z4 not, and Z5 not. Is that fine?
Yes,
so
sir.
now what were the
Yes, sir.
1, 2, 1, 1, 2. 1, 2, 1, 1, 2. Is that okay?
Yes,
So,
Yes, sir.
so in this case, what was my mu? Uh, we will just deal about like only this point, okay, x1 point, so that we can understand it properly. I'm just writing down like in 3 different colors. So first is mu z1 of, let's say, uh, 0th iteration of 0, right, which is kind of same of saying that mu z1
4.
of t of t, right? That's going to be 4. How it is 4? Because this we
All
are,
the Z1s, mean
yes.
of Z1
So for this one,
component.
right? So at tth iteration, I need to check it for uh, when it was 1. So it is like this point plus this point plus this point, right? So that was going to be 9 plus 1, 10, 10 plus 2 by this one, right? So then what happens to the second iteration? Second iteration, z1 of 1. So my point x1 is going to jump into what? Okay.
So second iteration, we used, this is the first iteration. Like we have not started our iteration, right? We just calculated the mean.
Yeah, correct. But just understand it. Like it's okay. You just think that these are the iterations because then, okay, z1 of it's getting hanged a lot. Z1 of 1. Can you just guys remember this numbers? I need this. I'll write it again. Can
Just
anybody
take a
take
screenshot, sir.
Yeah.
Yeah, taken, sir.
Taken? Okay. Maybe I'll just reload it. That will work fine. Yeah, tell me now. Just quickly.
X1, X2 to X5, I'll tell you. 9, 12, 1, 2, 3.
9, 12,
12, 1,
2,
2, 3.
is going to be
Z1 to Z5, I'll tell you next.
3, 4, 5. Okay. Now Z1 is Z1 of
1, 2, 1, 2.
Okay, sorry. Okay, just give me the numbers and then I'll write down. 1, 2,
1, 1, 2.
1, 1, 2.
Yes.
Is going to be Z1 of 1. Sorry, Z
Z2 of 0, Z3 of 0, Z4 of 0.
Z2 of 0, Z3 of 0, Z4 of 0.
I'm so sorry, sir. I think we've totally fried you.
No issues. So here mu, let's say
Z1 of 0 and mu 0.
I think it should be mu Z1, no, not Z1, right? So Z0, right? I think because one when I talk, then that means what? Like it's going to be, let's say mu 1. Okay, mu 1 of 0 is going to be 4. Mu 2 of 0 is going to be 10.5.
10.5. Yeah.
So that means that means to the second cluster and mean to the first cluster.
Yeah.
But here, if I just wanted to say that it is mu Z1 of 0 of
Rohit, can you unmute? Your background noise is coming.
mu Z, what is it? T of 1 of 0 is going to be 4, right? What does that mean? The first cluster, so it is the mean related to the first data point is going to be 4, right? When it is into the first cluster. Is that okay?
Yes, sir.
Okay, I think this is fine. Now, what next? I'm going to go for the first iteration, which is then what will happen here? This is more closer to this point, so the cluster indicator going to be changed to 2. Here it remains the same. Here it remains the same again, right? I guess. Yeah. Yes, right. Then here Z4 of 1 is going to be, is it going to change here or 2? No, right? And here it is going to change. Yes, right? I hope it is okay. But then what happens to the mu's, right? So mu of Z1. So Z1 is like the cluster indicator for the first point is going to be what now? In the 0th iteration, or sorry, maybe for the first iteration of the 0th data point. So, or kind of like that, right? Are you understanding? Okay, maybe I'll just go again back. What is this quantity?
New, that is the
Sum of
updated where it wants
is
to
going to be
go.
sum. That's going to be sum, right? So yeah, we are. Shall we do like? Shall we calculate all of that? Will that be fine? Maybe yeah. Okay, I'll do that. It's better. It's better.
Yes, so we spent like like 20 minutes in just this, like rewriting. Like we'll do it correctly once, and I think that'll be more than enough.
This is going to be mu zi, right?
Sir, could you please go fast? It's hard time.
Yeah. Yeah, I'm going to fast. Okay, then I'll just for faster going, I'll have to. I don't know whether you can understand it or not, but fine. So, so let's say mu zi of this is going to be 4, right?
Yes, sir.
Mu zi for this 3rd iteration. For what about this one? Z okay, that is not same, but
Yes, sir. You can actually show the first one itself, first value itself in that thing, how it relates.
Basically, see, it's just like if for this one, right? For this data point, my first that mu z1 of let's say tth iteration of this t, right? So that's going to be 4. Fine. For this second, for this data point, by the next iteration of this one, right? So in the next iteration, it's going to be into the second cluster, and that is going to be 7.5, which was this one, right? And mu z1 for t plus 1 and going to be t plus 1 is going to be what, you know, that's going to be 9 plus 12, which is 9 plus 12 by 2. It's 21 by 2, which is 10.5. Fine. So for my this data point, the distances. So what are going to be the differences here? So 9 minus 4 square, right? Then what is another quantity? It is 9 minus 7.5 square, and what is the next quantity? 9 minus 10.5 square, right? So initially we compare these two, right? In the first iteration, we compare these two, and what is happening? It's going to say this one, right?
Correct.
So then we assign the cluster. Okay, I'll just rub it here, and that's why the reassignment happened, right? The reassignment happened here, and we actually choose. So this was for cluster 1, this was for cluster 2. That means this x1 point, right? This 9 point goes into
cluster 2.
Cluster 2, right? And once it goes to the cluster 2, what will happen to the its centroid? Again, see, because the centroid has changed, right? In the next iteration after reassignment, then that value, this value has to be lesser than this or greater than this. Is it correct? Oh, sorry, not this one. No. This also has to lesser, right?
Yes.
You're understanding the point?
Yes, sir.
3 quantities are. So this is what, like, when
if it was lesser, then again it will change the.
Even if it goes to the second cluster, and if you calculate the mean of that cluster, right? This quantity later on, it also has to be lesser than the. So this is what to check, right? Whether from which data point it is. So this was the mean for the cluster 1, right? This was the mean for cluster 2, and these two means are at the timestamp t. At that point, we said that the distance of this point 9, right? It is lesser from
7.5.
mu2, right? That is mu2. But that at timestamp t. Now what you said, since it is lesser, I am sending this 0.9 into the cluster 2.
2.
Now, but once it goes into the cluster 2, the mean of the cluster will change or remain same?
I'll change.
It will change, and that change to what?
10.5.
And this change is mu2, but at timestamp
T plus 1.
This was mu2 at t. This was mu1 at t.
T.
But what we are saying is that now even if that mu2 has changed, the distance between this point and this point, right? It has to be lesser than the previous timestamp. In the same, right? So because mu2 has changed.
Yeah, if it's
yeah. So what is it here? This was
since it's greater, it'll stop, right?
Yeah, once it goes greater, it will stop. That is what my algorithm is there. But now, what it is showing, this will happen, right? This will happen. So this reassignment happens, and you will get it within the few, finite steps, because this point which is there, right? Once you reassign and all, that has to be the cluster center. You can actually check in the lectures again. You'll get it clear. But the understanding is here, this will happen in finite number of assignments, fine. And that means you are able to get the clusters which are which gives me the minimum value for this function. But that's not the only assignment. There may be the other assignments, because how many choices we had initially, I think we have looked at it, right? In this lecture, if you see,
k to the power n.
Right, so yeah, 3 to the power 5 possibilities were there, right? That means there is a chance that you will, because what you are doing here, once you you see this assignment first, right? Let's say, right? And you see that there is a change in the assignment, you go to the next. Can you go back to here? No, you're not going back again there, because now as you move forward, right? As you move forward, the distances are going to be lesser and lesser, right? Always.
Yeah.
Because it's going to, like, from, if I change it here and if I just go to the next cluster, the distances are going to be lesser and lesser. So that means you are striking it out, right? So let's say
we don't have to go back, right?
Yeah. So let's say you have some okay, this was let's say this was the cluster previously, x1 x2 x3 and x2 x5, right? Now I go to the cluster, let's say x2 x3 and
Sir, x4 x5, no?
x1 yeah, x1 x4 x5, fine. That means now we are not going back again here. This is done. This is crashed, right? Now if at all I am going again, right? So I'll go for what, maybe x2 x1 and x5 and again x1 and x4. This is possible, right? And suppose now after we have converged here, right? So that means my distance is not changing from here to here, fine. That means we like from Lloyd's algorithm, we are like, okay, this is my final solution. But how many possibilities are here? This kind of combination.
There are much more possibilities.
Yeah, so
way more possibilities.
Yeah, that means,
but because we reduced the distance between, we using this logic, we've gone to like a finite number. Is that what you're saying, sir?
Yeah, but that means we are not seeing the other possibilities, right?
Yeah.
So okay, here it should be 2.
But do we even need to see the other possibilities? That's my question.
Yeah. So I'll tell you. So let's say this, how many for this, right? Case k equal to 2 case, it is let's say 2 to the power 5. How many? 32, right? And suppose after third iteration itself, we are like, we said, okay, this is fine. This is going to be the, because Lloyd's algorithm says that the distance is not minimizing further. We have stopped here, fine. So that means out of this 32, we have just seen how many? 3?
2. Yeah, 3. Sorry.
And we are remaining there are 29. So there may be a chance that out of this 32, right?
But sir, we're calculating the mean, right? And we're reducing the distance.
Correct. But that does not guarantee me that that's the optimal cluster. Mean is not the only metric.
Okay. The minimum distance, there are better ways, you're saying, rather than minimum distance between points.
So
Because it's also many dimensions.
yeah, and yeah, that is correct. And one more thing, yeah, when we see it for 2 dimensional, it is like it feels easier, but it's not like with the higher dimensions. It's not the same thing, right? And the distance metric we are using is the Euclidean norm, right? There may be the other distance matrices also,
Correct.
right? So, but these clusters, they are finite, right? Anyway, the
For
choice of
this cat in
yeah,
Lloyd's.
yeah, Lloyd's also, and in general also, if I have like if I give you two choices, and if you have 5 data points, there may be 32 combinations only possible, right? So if Lloyd's algorithm goes, so what it says is it's going to be like check all the possible combinations and it will stop anyway. So since this is also, these possibilities are also finite, this may converge definitely. This is first argument. Second argument is that since we can converge without seeing all these 32, right? Because we have seen here only 3 and we didn't see the 29 others. There may be the possibility that those who you have not seen, they may be the
Would be better.
yeah, where maybe the distances will be like much smaller than this. But because okay, this how you arrive with this, we have started with random initialization, right? So if you initialize with something else, maybe x2 x1 x2 and say x3 x4 x5, you may arrive at some other solution, right?
Yeah.
So that means this Lloyd's algorithm is what? It is sensitive
Inefficient.
not inefficient, I can say that sensitive to initialization.
Just like Newton and gradient.
Right? Yeah. So that means if you have better initialization, you may end up into better clusters, right? Better choice of clusters. Fine. This is one argument. We are going with the random initialization. That means it can assign any random value of cluster indicators to the data points. So there is a chance that you can actually have a better initialization, and that better initialization, one of the techniques is k-means plus plus. Okay. This k-means plus plus algorithm. This is again the k-means algorithm only, but the initialization technique is different. And what is that? It will choose first cluster, right? First centroid randomly. Okay, mu1, and it will choose the second cluster based on the maximum distance, or let's say probability. Actually, let's say in that case probability is going to be based on the probability, right? So probability means okay, let's show the slides because we are out of time. So okay, I think yeah. What you do here, k-means plus plus, you choose the first one, right?
First mean.
First mean uniformly at random. So it can be anything, right? And then how do you choose the second one? Okay, this is another thing, but here it's based on what the, let's say this is my x1 x2 x3, these points are there, right? Then the distance of that mean, right? Like the okay, let's say it is a distance of that mu1 from x1 is 10, mu2 is 20, mu3 is 30, right? It will select that one which will give me the higher probability. Which is going to give me the higher probability?
1 by 2.
So what is 1 by 2 here? It is like what is the total distance? 30 plus 20 plus 10, right? Which is
60.
See, and divided by distances, and it will choose. So I'll show you in the graph how it is like. Suppose my data point 1 is here, okay, and suppose this data point is 1 2, okay. Another data point is, let's say, 3 3, and another is, let's say, 5 4. Fine. So my x1, my x2 is x3. Suppose you choose mean randomly as, let's say, 1 1. Okay. So what is the distance between this point and this point? 1 square. Let's say 1 square. What is the distance between mu1? Let's say this mu1 now, right? What is the distance between x2 and this one? 4 plus 4, 8, right?
2 root 2.
it's fine. You can tell me in the squares.
The-
These are
okay.
so it's 8. And what about this?
25.
16 plus 9, 25, right? Okay. So what you do is, what is the probability of choosing x1 as the second mean is 1 divided by 25 plus 8, 33 plus 1, 34. What is probability of choosing x2 as the second mean is 8 by 34 and it is 25 by 34. So it will pick the highest probability. So that means x3 will become my
Initial.
second.
We are proportionating. You know?
Yeah, proportionate. So what does that mean? You're choosing that point as the centroid, the second centroid, which is farther from the first, and it will be a good one, right? Good one, good indicator, right? Do you think that? So let us say we, yeah, I'll tell you.
Rohit, please unmute.
Mute. Unmute is.
So basically, like before, we had this problem of the initialization and being sensitive.
Correct.
Now you've made another method, basically saying that we'll do it with means.
Yeah. So let's say you have first mean, right? Randomly chosen. Previously, you can choose actually this point and this point also as a mean, right? See, in the k-means case, when we are trying to choose means randomly, what does that mean? It may pick this point as mu1 and this point as mu2. Is that fine? Correct. And now you just calculate the distance from every other point from this mean, and then you select the centroids accordingly, and then it will shift, right? Next step, it will make shift here, right? That is what actually we are doing in the k-means, correct?
Yeah.
But now what we are doing is, since it's k-means algorithm is sensitive to the initialization, we define means in a different way. Let us
You're
say,
doing probability.
yeah, so you're choosing this mean, right, randomly, and the second mean will not be anything else, because your second mean is not random. What you're choosing is what is the distance. So you calculate the distance from this mean from each data point. Now there is higher probability of choosing this, right, as a second mean. Now if that happens, then there is possibility that after few iterations this will converge to this, and that's going to be converged to this, and the final mean is going to be this one. Mu2 of, let's say, t plus 1 is going to be mu 1 of t plus 1. T plus 1. No. Both will iterate.
Okay, of the next one.
Yeah. So this was like initialization only, right? When I just say this point, this is initialization. This is better initialization now, right? Choosing this as second mean, mu2 of 0. Now you iterate again, and what will happen after the iterations? Maybe the means will get distributed. So I don't think this mean is going to change at all, because this is going to be 3 points only. This may go to here. Like after some iterations, this will converge here. And that is going to be, these are the final means, right? That is what
So,
happens.
sir, which is better, k plus plus? Like, I'm just.
Plus is better.
K plus
Better,
plus
okay.
is better, no? Probability.
Yeah, because it is sensitive to this one, right? So k means plus.
So that to solve that problem of sensitivity, these guys came up with this thing.
Correct. And now you had one more problem: how to choose k, right? Which k is better? So for that, there is no like proper method. There is a trial and error method, right? So what you do is you have this. This is what objective function we had, right, earlier.
Yeah, minimization.
So you penalize this, right? So if you have like large number of k, you don't choose it, because why it is bad to have large number of k's?
It'll be computationally expensive anyways, I guess.
That is also there, and it will not produce the good clusters anyway, right? So if you have the 6 points, let's say, how many k you can go?
Yeah, you don't want to go to 6, then it's
6, right?
pointless. Yeah.
Even if k equal to 5, it is not a good cluster. So for this kind of data points, right, how many are the better ones? 2, right? Not even 3 also, right? But 3 is also fine. You can go for 3, but one is good. It's bad.
No.
One is bad, right?
The whole thing can be taken.
Yeah, and 6 is good. that also is not good. So these extreme cases are not good. Maybe with here somewhere it's fine. So if any large value of k is there, we try to penalize it, and with the penalty function it looks like this. So if you penalize means what? You're increasing the value of objective function, right? And your goal is what to have this objective has to go minimum, right?
Minimum.
So if k is going to be higher and higher, I am going to add some quantity. That means penalty, where like as you go higher, right, we're adding penalty more, right? So objective function has to decrease, this is going to increase. So this is the best choice here, right? It's going to be or somewhere here 3 and 4, between 3 and 4. You understand? So this is a trial and error method. So you give all values of k, and how many k's can happen from 1 to
1 to the number of bins.
Data points, right? Total
Yeah,
number
maximum number. Yeah, correct.
The maximum number is total number of data points, right? So
Data
you
points,
have,
yes, correct.
n as the number of data points. So you go from 1 to.
So I'm still understanding, like, okay, now objective function, this graph, you're reducing because that's your goal. Like you want to constantly reduce.
Yes.
Now penalty is the same k, right?
Penalty of k. No.
Like,
so
what is penalty of k?
It's a function of k.
Okay.
As you go higher and higher, we penalize it. So that means if k.
What do you
is
mean
large,
by this? It's an adjective, penalize, as in like we add negative weights. What do we do?
You if you so let's say if your function is like this, suppose f of x, right, and your goal is to minimize this, fine. And if you are saying that I'm going to add some penalty, okay. So what do you think, if my objective is to minimize, it should be negative or it should be positive? If I
Negative.
No,
positive.
If I have negative, then this function is going to in a negative.
It's going to go lesser more. We want to increase it.
So if you increase it, then only it will have some restrictions, right? As you understand it, if you have k 6 here, right?
Got it.
The it's going to be minimum, because every point is actually equidistant from each point. So okay, let's say you have k equal to 1 in this case. What will happen? It will have some distance, right? It will be larger, like the largest one, correct? Because its mean is somewhere here, and it will have some. As you increase, so if it becomes 6, let's say, it's going to be 0.
Then you have the minimum.
Minimum
Zero,
is 0, right? Because from each data point, so if you have 6 data points and if you have 6 centers, what will be that? Like nothing, right? So if like the distance.
Sum of all will be nothing. Yeah, 0.
0. So that means as you increase this k equal to 1 to 6, right? And let's say k from 1 to n, what is going to happen? The objective function is going to get decreased only, right? And it will eventually go to the 0, right? For k equal to n, correct? But that means but your objective is correct. Your goal is to minimize it. But until what point? So should I go to 0? No, right?
No.
0 is not a good thing. So that means I have to do something about it. So what I'm doing, as I'm going from 1, 2 and more, I'm adding some values, the positive values there, right? So that my function will understand that, because see, the cumulative is what here? Cumulative is
We're adding the same kind of.
So addition of this point and this is what?
0. 2.
Higher.
Here, right? Higher.
Yes, sorry.
This and this will be somewhere here, right?
Yeah.
But still it is lower side, correct? This point and this point is here, right? Here. But what about this 4? Let's say this and this is going to be here, correct? K and this is, even though it is 0, but with the higher point, I'm actually going somewhere here, right? So my graph is going to become the sum is going to become like this, right? So which one should I choose now? Where the sum is the minimum. So I'm not end up choosing k equal to n. I'm end up choosing k equal to 3 because of this penalty.
So if the function at F3.
Hmm.
We are summing twice now, so it will be 2 F3 now.
What is it? What is?
So 2 times F3 now. It will
Why?
not be at that point only. So if that increasing function, we are adding the increasing function and that decreasing function.
Hmm.
So at that minimum point,
Hmm.
the point at which it is intersecting, if
Yeah,
we are summing both
yeah,
the points,
it can be like this also. Right?
I,
Oh, sorry, it shouldn't be like this, right?
I am
It will still increase, right? It has
Yeah,
to.
so it should be addition, right?
Hmm.
Okay, I'll tell you how it is
it should
working.
not be at that point only.
No, it should. Okay, sorry, 1 minute, 1 minute. So let us try to understand this functions thing, right? So on the x and y axis, I'm drawing it here. So this 1, this 2, this 3, this 4, and let's say you have 5 and 6. So my k 6 is equal to n. Fine. At 1, let's say it is this value is 5. Is that okay? What is here? The value of my objective function, right? And as I go, it decrease, and it will go to 0 finally. Fine. So let's say at 2 it is 3. That means it decreased, right? So I choose from 1 to 2. If I choose 2 clusters, it becomes 3. Here it becomes, let's say, 2. Yeah. And then here it become, for 4 it become, let's say, 1.5. 5 it becomes, let's say, 1. And then eventually it goes to 0. Is that fine? Now I'm adding 1k penalty function, right? So if I increase to larger k, I'm going to add something more. So now it is here, it is, let's say, 0.5. Okay. For k equal to 2, I'm saying it is 1. For k equal to 3, I'm saying it as 2. For k equal to 4, I'm saying it is 2.5. For k equal to 5, it is 3. K equal to 6, it is, let's say, 8. Right? So what will be the resultant sum should be? So for k equal to 1, it is going to be 5.5 plus 0.5. To be 5.5, right? For 2, it is 1 plus
4.
3. 1 plus 3 is going to be 5.
1 plus 3 is 4 or something.
Sorry, okay, 4. It is going to be 4, right? For 3, it is 2 plus 2, or what I
3 plus 2, 5.
no, 2 plus, this is 2,
30.
right? 2 plus 2. Again, it is 4, okay? But maybe I can just reduce it to 1.5, 3.5, let's say, okay? For 4, it is 2.5, and let's say it was 1.5 I said, or what? Okay, how much it is then?
4, sir.
Huh?
4, sir.
4. Okay. And 4 is
2.5 plus 1.5 is
4. Okay. And okay, numbers are might be like confusing, but it is okay. 3 plus 3 is going to be 6, right? It's going to increase here drastically, and 6, and 0 plus 8 is going to be 8. So I'll have this kind of curve, right? So generally it will be a smoother curve, but since we have taken random numbers, it is looking like this. But what does that mean? Now I will not choose based on this objective function alone, because if I choose on this function, what will happen? I'm end up getting choose like 6 as the k. Instead, I will choose from this graph, and then I think the better one is what? The choice between 3 and 4. So either I can choose 3 clusters or 4 clusters.
So is there some mathematical way to get the penalties?
Yeah, correct. Yes. But that works, right? That's going to work anyway. It's a function of. So what it is saying here, it is a function of. Its objective function is this one, right? And it's going to penalty of k. That is a function of what? This. So what kind of function? It will be higher value for larger k. Okay. Anyway, it will this will be there like in a regularization methods, right? In linear regression case, we will discuss it more. But for now, you understand that how we are choosing the clusters, number of clusters. Is that okay? Okay, I think I have covered all of the things. but I think I have not covered this nature of clusters. Maybe in the upcoming session I'll talk about it, or you can watch it from the lectures. It is clearly understandable from there also. But major part I have completed it today.
So what are the important parts for week 3?
Mostly it is like how you are going, like, do you understand how assignment happens? The algorithm itself is a major part.
Okay.
Okay. Yeah. Yeah. So whatever is the remaining, I think the it's getting almost very late. So whatever
Yes, sir.
doubts you are having, right? So we will discuss it on Friday. Anyway, I am going to conduct the session on Friday. So we will just talk about that later. Okay.
Yes, sir. Thank you for the session, sir.
Sir,
Yes.
sir, do we have instructor session tomorrow?
Not tomorrow, Friday. There are 2 sessions only, instructor sessions 2, which is on Monday and Friday. In
Or it is showing tomorrow at 6 p.m.
I think that is TA session, but okay, we will change it. No issues. But it's not there. Instructor sessions are 2 only. Okay.
Yes. So thank you, sir.
Okay, thank you guys.
Really appreciate it. So much patience.
Thank you, sir. Hello, sir.
Yes.
Sir, I got a doubt, small doubt. Means,